One of the most frustrating experiences as students is perhaps the fact that you're always playing catch up. Doesn't matter how many courses you take, it doesn't matter how hard you work, you always seem to be behind, right? There's always something new to learn, and it seems that this thing never ends. Today, I will be able to take you to the front of the line on a topic where I can guarantee you will be ahead of just about everybody on Earth. I'm going to talk about something which is very new. It's still developing. You will see that I myself, in some of the things that I'll be telling you, I'm still learning and discovering. This is one of the areas in which I'm most active. I learn new things myself every day. So in your struggles to keep up and play catch up, I want to remind you of the history of Hercules. Are you familiar with Hercules? The Greek myth, Hercules. Hercules is a Greek myth. Is, according to Greek mythology, is the strongest man ever existed. He was given, I think, 21 impossible tasks to kill the Nemean lion. This is the lion that no sword, whose skin no sword could go through. You can kill it. So what he did is he just decided to just fight the lion and use his own nails to go through his skin and kill him that way. That's how the history goes. He had to kill the serpent Hydra, which had the characteristic that if you kill its head, 2 new heads come up. So it seems that you never end. That's very allegorical to how you probably feel very often these days. So what he did is he got someone's help so that when he killed the head, the other person would cauterize it immediately, burn it, so no new head would grow, and that's how he killed it. He was asked to find the apples of the Hesperides, which he did by just having a network of friends who would tell him where they are. So the secret to that is that if you fight problems alone, you never win. But if you are collaborating with others, then you have hope. So I want to be that for you today. I want you to come to the front of the line on a topic that no one talks about. It is really not in academic courses, but this is where the money is going. And I want you to at least hear this, because in a few years, you may see some opportunity in the distance, and it may not seem like much. But I want you to at least get the view that maybe there is something there that you can be first at getting, and then it's yours. You've learned to raise your hand when someone is offering you a job, and I hope you don't forget that skill. If that's the main thing you learn in my course, then that will be wonderful. So I want to start by giving you some idea of the size of asset management entities. You know where I'm going with this, because I told you yesterday. But today I want to reinforce that with precise numbers. Here I have a chart with the GDP of the largest countries. USA, about $30 trillion. China, about 20. Germany, 5. India, 4. We could throw BlackRock in there, almost as big as China. You can throw Allianz there, 1 trillion. So 25% of India. That gives you an idea of the big asset management entities. This is what it is. So if you want to say that you are the manager of USA as an entity, it's more than the president. If you're managing that country, then you're managing that. Let me compare that with some other quantities. Let's say that I take all the gold in the world, all the gold which has been mined and remains to be mined. This is mineable gold. This is not gold which is unmineable. You know, a few grams here, a few grams there. You can find that. That's much bigger. Okay, this is the gold that could be mined, and at market prices today. And you know, gold is very expensive right now. Okay, sure, it went down by like 5% on Friday last week or something, but it still is very expensive. So all the gold in the world that has ever been produced and will ever be mined is about the size of the US economy. So if you're a gold trader, then you have a big market to deal with. And actually gold was one of the commodities that you use to create your commodity index. So this is something that you've already been dealing with. Okay. If I look at all the oil in the world at today's prices, it's even bigger. It's $220 trillion. I like to say that every era in human history has a commodity. Of course, we know the age of bronze. Bronze changed humans, and then iron changed humans. But you can attach the evolution of humans to a particular commodity, and clearly, oil has been the commodity of the 20th century. And a lot of what's going on in the world today is about oil. So yes, oil is a defining characteristic of humans, and well, for a good reason, $220 trillion. And this monetary fact has a lot of consequences. And that's why countries are fighting for this. But now let me go to the 21st century. I have no idea what the 21st century is going to look like. No idea. But let me look at some numbers. If I calculate the value of all the photovoltaic energy we get from the sun, it's $400 trillion per day. So it's orders of magnitude bigger than the value of all the oil that exists in the world, underground, above ground, in Venezuela, in Iran, it doesn't matter. Is twice the amount of oil per day. 100 years ago, this number was not even known 100 years ago. Because 100 years ago, although we knew that in theory you could have this thing happen, we didn't know how to do it. We didn't have the technology, we didn't know how efficient it was. And here I'm using the technology of with the efficiency of modern solar panels. This number could increase, not decrease in the future. So I want to look into the future. I want to have an idea of where things could go. Now you can see that the GDP of the entire United States is like almost invisible in that chart. And this is on a given day, on a 24-hour period, yes.
But that's the energy, not the energy we are currently capturing. Right?
No, that's the energy we get from the sun. Most of it is, I'm not going to say wasted. In fact, I'm going to reflect on where that energy goes. It is not becoming electricity that we use. If we could, our energy problems are solved. That energy produces about 1,000 times the entire energy requirements of the Earth, of humans, not the Earth, of humans. The Earth needs a lot. Actually, the Earth is using a lot of that every day. Okay? So I'm looking into the future. I'm taking a little peek. But from this perspective, I would have to say that the world has to change, given that we can capture that now. Okay? So let me consider the Earth as an asset management entity. How does it work? How does the Earth work? So on Earth, we get the sun. Let's say as light, photovoltaic energy, whatever. We get the sun. We have water. And we know that with water and with the sun, that creates rain. So creates a water cycle. So you see the Earth is using some of that photovoltaic energy from the sun, not to produce energy for your MP3 player, but to create a very useful water cycle. Water evaporates, goes up and then comes down, right? And then the water cycle is good because it helps to create biomass. The biomass, what happens with the biomass? This is, again, the sun. The sun is our main source of energy. The sun creates biomass. The biomass becomes part of our food cycle. And eventually is where oil comes from. So you can think that oil is the accumulated solar energy we have had for billions of years. Right? So I'll continue with that. And the sun, of course, creates plants, which we use as the fundamental part of the food cycle. The food cycle starts with that. Animals eat it, and some animals then eat the other animals, and eventually we all become biomass, and then we all become a little drop of oil that billion years from now, maybe someone wants, most likely not. Oil is probably going to be useless in a few years. Too hard to get and not really very efficient. It's a very inefficient way to store energy, right? So how are humans managing this? Now, this is the Earth. The Earth has managed itself without humans for a very long time. But then at some point, the humans came into the Earth, and with the humans are having a noticeable effect on what we're doing. So we're creating electricity from the sun with the solar panels. Humans are doing that. The Earth did not do that by itself. The Earth did not need it. The Earth was very happy taking the energy from the sun and turning that into a tomato, into a tree, into a storm, and that's how the Earth manages itself. We have an atmosphere, and the energy from the sun creates differences in barometric pressure. So that creates wind. So we figure out a way to harness that wind and again create electricity. And we have taken rain and figured out a way to accumulate rain into potential energy that we can turn into electricity again. So electricity has become, it's about 100 years old. It's very new. Sorry, human managing electricity. Electricity has been there since the creation of the universe. It's always been there, electrons moving back and forth, right? But humans have managed to manage it only very recently. And that changed everything. That's why we have electronics, right? That's why we have data centers. And our data centers are using a lot of that, but this is just the beginning. Today I want to speculate as to where that's going. But I'm going to look at this from an investment perspective. Although my course today is going to be on science fiction, I'm still going to approach it from an investment perspective. This is not a course about creating new energies or even new ways of creating a solar panel. I'm not talking about that. It's also not going to be a course on environmental science. Although I'm going to use the environment as an asset management framework. And oil is very interesting because we've learned to take oil, and oil has been the main source of power for the last 100 years. 100 years, which is nothing for human history, right? So that's where we are now. This is what the humans are doing when it comes, as asset managers. And there, given what we've learned in this course, I would say that some of that is what I would call active management. Going back to our example where we discussed the Sharpe ratio, and I think it was Yunchin. I think you were the one that I paid you $1 million if you make 5%, right? Yeah. And that gets you to act in a certain way and optimize the Sharpe ratio. Well, and then you became an active manager, right? So you are that. That's the way we are getting that. This is alpha production in the language that we've developed in this course. So photovoltaic, wind, and hydroelectric power will be active management. What would oil be? That's beta, that's passive management. You don't have to do anything. This energy has been stored there for a long time, you just use it. But there's further financial analogies. This is the similar thing to quantitative easing that the Fed did in 2001, and we went through that yesterday. Why? Because these are the energy reserves that we have on the earth. You don't have to produce it. You don't have to rely on the new energy that's given to you. This is as if you have the ability to buy Netflix when it was worth $5. And no, thank you. I will just buy the index. Or I'll just tell my central government, print more money. So a lot of the activity that we have been doing for the last 100 years has been quantitative easing at the planetary scale. Just get the oil which is in the ground. Using the central bank reserves, which seem to be very large, to just continue. But every economist will tell you that you can only do that for a while. That creates inflation, and eventually you run out of money, and then you have to figure out you need a real business. You need an active manager to produce something. So, and we're at that juncture. And a lot of the discussions that you hear in the news, politicians, and in general, people who don't know what they're talking about, is about this. Shall we stay with the consumption of central bank reserves, or shall we get to work and create new profitable enterprises? And now you can draw your own conclusions as to the different decisions that the different asset managers for humanity are doing. There's a very big push, for example, in the United States right now to continue to use central bank reserves. Of course, the United States is very good at it. That's what their economy has been doing for the last 50 years. Just borrow. That's why they have that huge deficit. Or you can do what China is doing. Say, no, thank you. By the way, I don't have that. What I have is a lot of sun. So let me go and look for the other active management activities that create new assets. A beta producer and an alpha producer. Yes? So let me move forward and talk about something else. I cannot talk about everything that's happening about these things for two reasons, because I don't have time. I actually don't know. I'm learning this myself. But let me talk about water for a little bit. I have here a paper that talks about making AI less thirsty. You may have heard this. You probably know, so who uses ChatGPT or equivalent? Okay, great. I do. I do it all the time. Okay, everybody does it. Okay. You probably know that there is a lot of criticism, I don't know by who, about the water consumption of large language models. Have you heard that? Yes. So I have it here, and here's a paper. And in that paper, it talks about the fact that ChatGPT, this is just for the training part, it consumes 700,000 liters of water. And some people think that's a lot. So I have here a graph. The graph is the following graph. I'm choosing units which are very shocking. The units which I'm using is, I'm not going to use liters of water because we don't really understand what a liter of water is. At a planetary scale, we don't. The unit I'm using is, who here eats meat? No vegetarian people? No? No one is a vegetarian? Okay, then what I'm using is the amount of water needed to produce all the meat that we eat. Each of us, one person per year, which is 100,000 liters. That's the water that's needed to create the meat that an average human eats. So ChatGPT consumes the water that 7 meat-eating humans consume in a year. So if you're very worried about the consumption of water by ChatGPT, just call 6 of your friends and all decide to become vegetarians. And you're done. You have neutralized the water consumption of ChatGPT. So why are we talking about that? Why are we talking about all of us becoming vegetarian? Some people have tried, and they were made fun of. And now here we have papers and scientists and people worrying about the water consumption of ChatGPT. And the reason is that no one has done this calculation. You don't need stochastic calculus for this. You don't need Ito's lemma. You need elementary school math. You need to add things. So the amount of meat that we consume, just us, is more than ChatGPT. And if you look at all of the global AI with all of the data centers and everything, that is the water consumption from the meat needed to feed 50,000 people with meat. So Munich has a bigger water consumption than all of the data centers and all the AI in the world. So why are we talking about the water consumption of the data centers and not about how much water is needed to feed meat to people in, forget about Munich, it's too big, Garching, right? Why isn't Garching in the news talking about the water consumption of Garching, and yet we have this thing in the news? The reason is that there is no accounting. And in this course, we've learned the value of accounting. We learned that accounting was introduced in 1933 as a regulated activity. GAAP principles were developed as a consequence of the 1929 crisis. And without proper accounting, forget about investing in the stock market, you cannot do it, because you don't know what you're buying or selling. And that's where we are right now. So in the analogy of the rest of this course, we are in the 19th century trying to understand how to invest. But in this case, it's not invest our money, it's invest our natural resources and to plan our activity as to decide what's important and what is not. Of course, if you go to all the United Kingdom, it's 100,000 people that if they eliminate that, and then for the whole world is 7 billion. So you can see that these quantities, if you put them in the right context, then they have a completely different meaning. And we're still discovering this. By the way, you may be the only people in the whole world who know this, because I don't know anybody who knows this, by the way. Okay, there may be someone in some country, but you are now no longer trying to catch up. You are ahead. Just be aware of these things, because these things will be driving not just capital markets, but everything we do. Today I'm going to focus on capital markets. But it'll be driving everything. It'll be driving innovation. It'll be driving everything. Okay? By the way, what's the value of water? I wish I could do the graph for the value of the water we have in the world, over which maybe soon we're going to start to fight for. I mean, maybe photovoltaic energy goes everywhere more or less evenly. Some countries like Spain get more. Some countries like, I don't know which country, maybe Norway gets less. But water, it's very hard to move, and it's there. We don't get new water. Water is just there. And people can live without gold, but they cannot live without water. And the management of water, and I don't, do you know the price of water? If a bottle of water is like $1 million a ton, bottled water. It's hugely expensive compared to oil. And yet, we consider the use of water as something that we can not even care for. So I gave you the backdrop for what I think is going to change things. And now what I want to do is I want to go back to capital markets and talk about how this could affect the world of investing. And I like to start with an observation, something that happened in the year 1990. It was a very big shock. I mean, I don't think you were around in 1990. I don't know. Look, I'm not going to say, but certainly you probably were not aware of this fact. And I was aware of this fact. I saw it develop, and it was very shocking. It was very shocking. Let me try to reconstruct history so that you see how shocking this was. And you can learn from that. In the 1980s, the best companies, like the OpenAI of capital markets, were tobacco companies. I know it's very hard to imagine, very hard to imagine. But it was what every investor wanted. And there were tremendous fights between investors to try to snatch the tobacco. They were the most profitable companies. There was a sentence coined in the 80s, which is, you make it for a penny, you sell it for $1. So a cigarette costs 1 penny, and you sell it for $1. So like the most profitable business. Everybody wanted to buy the tobacco companies. They were like the OpenAIs of the world, like this, the holy grail. The dream of investors was to own tobacco companies, the most profitable companies in the world. 80s. Smoking was, you could smoke everywhere, you couldn't smoke on airplanes. It was disgusting. But it was great for the business of tobacco companies. It's very hard for you to imagine that, I know, because now the world has changed so much. Airplanes had the smoking section and the no smoking section. But that was great because you go anywhere else and everybody was mixed. I mean, you could be smoking right there. And then I have to stand the smoke. Yeah, it was disgusting. Yes, I know. Okay. That was the 80s. And those companies were like the most sought after companies by investors. And in the midst of that, with hedge funds fighting to own this and doing reverse IPO, all sorts of things, then here comes one of the icons of institutional asset management, Harvard University. Actually, not the university, it's called Harvard Capital Management Corporation. It's the entity that manages the endowment, the money of Harvard University. Today is about $35 billion, it's pretty big. Harvard has had the largest endowment of all the universities in the world. Universities outside of Germany have money. They have an endowment. And the endowment is not from tuition fees only, it's mostly from donations. People give them money and then they collect it and then they do things with it. Okay? So universities have assets that they manage. And on May 24th, 1990, there was an article on the New York Times, which I read. I read it on May 24th, 1990. This is the article. I want to go through that. Okay? I've tried to prepare you so you, I mean, I know you're not gonna be shocked, of course, but back then it was a big shock. So try to read it with the eyes of someone from the 1980s, okay? So Harvard University and the University of New York have decided to divest of the tobacco stocks they have on their portfolio. There's an additional layer of surprise for this, which is the word divest became very popular in the United States in the 80s. Divest is the opposite of invest, okay? Became very popular because everybody was asking, well, everybody was rioting even. They were asking for the divestment on South Africa to protest against the apartheid that was happening in South Africa. You may know about the apartheid and maybe Nelson Mandela in South Africa and this and that. Are you aware of that? It was a big social movement around the world to defend the Aboriginal and the black population in South Africa, which were jailed and tortured and this and that. And everywhere you went, especially every university you went, there would be big protests asking the university to divest from South Africa. When I read that, I said, tobacco? You mean South Africa, right? No, tobacco company. What? Divest from the most profitable companies in the 80s? Not from South Africa? That was shocking. It was very, very shocking. And the reason is because it kills their customers. That was their analysis of the tobacco industry. Why do we invest in companies that kill their customers? Most of the investors will say, I don't care, but they do. They make a lot of money. Make it for a penny, sell it for $1. What's wrong with that? Their customers want to buy those things and die. That's their problem. You understand? That's how the thinking was. Now, we don't think like that anymore. No, we've changed. But that's where you like to look at the gradient of history to understand how things could change in the future so you can take advantage. So I have here a graph trying to understand quantitatively what Harvard's decision was. I started this graph, so I'm comparing to, it was hard to get a stock in the tobacco industry that was not really prepared by takeovers and this and that. So I took British American Tobacco. It's just one company. And I compared that with the S&P 500. And again, this looks silly that I'm doing this comparison. I have a point, okay? I have a point. Clearly, Harvard did not do that to beat the S&P 500. We know that, and I know that, okay? But still, bear with me, please. Let's look at this because there's some lessons to learn from here. So I started my graph in 1990 when this decision was made. And it looks like it was the right decision around the year 2000. The S&P 500, which is in orange on this graph, clearly outperforms that. Again, I'm telling you, this is not the reason it was done. And this is not where I'm going with this, okay? So it looks that was the reason, that it worked. But then if you go to 2008, 2010, clearly not. The tobacco company has done better. But again, that's not what matters in this graph. What matters in this graph is what happened around the year 2018. What happened in the year 2018? There's a sudden drop in the stock price of British American Tobacco. And why was that? That's what I want to talk about. Regulation, decreased demand. People eventually said, you know what? I actually never liked smoking. competition from alternative products, but the most important for us today is litigation risks. Companies, tobacco companies, started to be sued left and right, and they kept on losing and losing and losing and paying millions and millions. They were still profitable. Okay? But that paired with something else, and that's what I wanted to, this is the purpose of, which was social concerns. Besides all of that, which, by the way, those financially, yes, had an impact on the valuation of the companies, but alone, no, they're still profitable today. They still make it for a penny and they sell it for $7. They still do. And they're very profitable, especially in developing countries where the smoking culture is still very strong. Big deal that people in the United States do not smoke. That's 4% of the world population. Who cares? Big deal people in Germany don't smoke. Like 1% of the world population. Who cares? Oh, I've lost 1% of my customers. Okay. That's not it. What happened is those 4% of the world population have a very big share of the world GDP. And they are the ones who decided, you know what, I don't like this stock. They did in 2018 what Harvard did in 1990. That's what happened. And many people don't like to buy stocks, and people have becoming socially responsible when it comes to their investments. That has happened. That is happening. We talked about GameStop just about every day this week, right? Same thing. GameStop is very much discussed and talked about, and it was a group of teenagers that did that, but everybody's doing that today. Social trends are having an impact. So that means if social trends are having an impact, we should look at social trends and see what people are thinking, right? And this is one of the things which is going to be a big deal. This is the beginning of the ESG market, which I'll tell you in some detail, okay? Okay. So how did Harvard come to this conclusion? This is the first, we're going to do a lot of these today. The first example of risk thinking is that for us today. I want to tell you about risk thinking, how you do that. So Harvard thought something like this. I have tobacco companies now. So I'm going to give up profitability today, very profitable companies. I don't think they did it because they thought that they were going to be sued and they would lose millions. And I don't think so. And even if they did, the lawsuits are really insignificant compared to the money they make. But you know what? I want to give up profitability today for possible lawsuits tomorrow. Because this is something interesting that hasn't happened yet. Actually, there's one case. Imagine the situation where the lawsuits are no longer against the tobacco companies. Imagine a situation where the lawsuits are against the shareholders. You say, no, that cannot happen. The shareholders have no liability. Explain that to a judge. Because especially in North America, they say you can sue a ham sandwich. You can sue anybody for anything. And you see that in the news these days, right? And there is a case. There's a case 2 years ago, I think. I don't think it's going anywhere, but the board members of Shell, the oil corporation, were all sued by someone because of climate change. I'll talk about that later. Again, I don't think it's going anywhere, but look, considering what might happen is something that you must always do. And I want to give you the framework of exactly that. This is what I call risk thinking. Making decisions where you don't really know what's going to happen. Okay? And unless something has probability 0, if the probability is 5%, you need to consider it, even if the probability is 5%, especially if the consequences are very severe. So that's what Harvard did. And this is something that we now know very well. We've been looking at that for the whole week, which is the relationship between the price of risk and the price of time. And by the way, Harvard makes decisions with a 30-year or more time horizon. So if this thing, so for them to make a decision in 1990 for something that will happen in the year 2018 is, you see, told you so. It's not too distant. It's not too far. So this was the beginning of a whole area of investing, which is called impact investing. I'm not going to talk about that. I could just be aware that it's a chapter I've left untouched in this course, which is impact investing. But at least I'll make it up with this one, which is really forward-looking. Impact investing is old. It's been around for 20 years, and what I'm talking about is the modern version of impact investing. And what impact investing is to have a general awareness of the consequences of one's actions. And there's no Sharpe ratio there. At least we don't know how to do a Sharpe ratio of impact investing. We will still be able to quantify this somehow, and I'll show you how. I'll show you how we can quantify this with certain skills which you are very good at, all of you. I'll tell you, okay? I'm coming to that. But this evolved into this thing we called ESG, which I will tell you in some details, okay? Hoping that it will become a rules-based, well-defined set of procedures in place to make decisions. So it's not there yet. We may have that for ESG. Very likely ESG is going to be phased out and something else will take its place. Maybe with more acronyms, maybe with a more modernized vocabulary. We don't know, okay? ESG is probably dead in that form. It'll become something else, and I'll tell you that. And this is what today I'm going to be talking about as the path towards sustainability, which will link to how I started my discussion today. So impact investing, I like to say, is the new liability. It is becoming a part of everybody's investment decisions. For example, we are in Germany. Insurance companies in Germany are governed by this thing called Solvency II. It's the last wave of insurance regulation. Anybody who has been at an insurance company, doesn't matter what you do, could be investing, could be payroll, whatever you do, Solvency II affects the business of all insurance companies in Europe. And Germany is the world capital of insurance still. The largest insurance company in the world is Allianz, and it's here. So, Solvency II requires investment companies to take into account the new liability. They call it ESG, but it's really, I want to talk about more than that. So you have to be aware of that, because this is a risk factor that goes along your investment activity. And that is really asking or favoring insurance companies, when they invest their assets, to make investment decisions which are aligned with certain objectives which are not monetary. I'll tell you some more about that. So all of this is, let me go to the source. The source of this is the United Nations Sustainable Development Goals. I don't know if you've heard this term. The UN SDGs. Usually people call them SDGs. Sustainable Development Goals. It's very long. It's a mouthful. Sustainable Development Goals, SDGs. So I have the 17 SDGs here written on the right, and I have the symbols in a very nice chart on the left. This was a remarkable achievement of the United Nations. 193 countries agreed that this was something worth pursuing as humans altogether. No poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, and so on and so forth. The word water appears twice. 9 of these are dependent on water. It's a very interesting set of objectives, and all countries agreed, okay? The United States was there too. They're not, but they were there, okay? It was one of the 193. The government said, well, if this is important, they did something good. We said it's not just something that is good to make a statement. We need to do something about this. So if it's important, I'm going to go to my home country, and all countries did that, and I want to see what I can do as lawmakers, because governments, the only thing they do is they speak, which has no impact except people listen, and make laws. That's the only thing they can do. They make laws. So laws have been changing differently in different countries so that these objectives can be obtained. And yes, they have affected the investment sector. And yes, a lot of these things are affecting the investment companies in each of the countries differently because each country did this differently. There was a lot of alignment years ago. Now there's a little bit of a misalignment, but I suspect, again, I think it's my obligation today to tell you not only what is there, but also what I think is going to happen. I have to give you my opinion because no one really knows, and no one has a crystal ball. Okay? But I think there's going to be a realignment with a new world order that's developing. There's probably going to be a realignment of that. And this is going to sound very weird because you're in Germany, but the countries that care the most about this are the countries that are becoming more powerful as we speak. China in particular, all of Asia. So there's very likely going to be a realignment so that these things will be then led by some of the new world emerging powers. And the country that is very vocal against all of these things, the United States right now, will probably continue to be very much against this, and that would probably create some sort of a rupture. Perhaps, we'll see. And that is going to affect the investment sector, guaranteed. I'll show you examples in how this is going to affect the investment sector. So I want you to be aware of that. Yes, Leon.
This sounds like Ray Dalio, actually, who is also saying that the world order is changing.
Yes, I agree with some of the things that Ray Dalio says. Others I disagree. Look, he knows more than I do. Okay, if you have to listen and pay attention to someone, listen to him rather than me. But I still have my own opinions. I move in different circles than Ray Dalio. Okay, and perhaps I go to China more often than he does. Perhaps. I mean, I am pretty sure I do, but I'm sure he knows more about China than what I do. But I get to see different things. I travel to a lot of countries. I go roughly to 20 countries every year, and I usually go to places like this. I pay attention. I talk to people in each country, people that matters. Usually, my meetings are not with just cab drivers and hotel people, So. No one really knows. Really, no one really knows. Okay? I don't think anybody knows. But I get to observe certain things. I see what happens. So today, I'm sorry, it's going to be a mix of math and opinion because I want to give you some foresight. I am sure that all of you are going to be given an opportunity to enter into something very, very interesting in the next few years. And very likely that great opportunity will be in this area. And it's very likely you will not even bother to look in because no one has told you that that could be interesting. My purpose today is to tell you some things so that when that happens to you, you can maximize the success of whatever it is you decide to do. Okay? So that's why I'll tell you what I think. And by the way, in my YouTube channel, I have certain playlists which I do for my students. One is on sustainability. I have a lot of very interesting videos there you can go and watch, and I've curated them for you. I have also some videos which are just funny. Okay, it's not that I agree with what they say. I think it's a very nice. Sometimes you need humor to approach these things, and so videos I just put them there because I think they're funny. So what I want to, so with these goals, with these 17 goals comes 169 targets. And then events and publications and actions. And it's a very well-structured activity that the United Nations did. So what has happened is that these goals, actually more than the goals, these targets have been classified into different objectives which matter for the investment sector. And those objectives have been classified into what's called pillars. There's 3 pillars. The E pillar, E for environment. And these are you can see there, these are the targets that have to do with the environment. So to consider the use and dependence on fossil fuels, access the central bank of the earth reserves, right? The use or management of water and other resources. We talked about that. Pollution, we didn't talk about that, but pollution is a concern. If your investment activity leads to pollution, then you should consider doing that. And in Europe, this is regulated for insurance companies. Only for insurance companies just yet, okay? But probably other banks have some sort of a target list they've been given, but I don't think they're regulated like insurance companies. And so on and so forth. Carbon footprint, renewable energies, climate change. I'll tell you about climate change, okay? I don't want to say anything about climate change until I tell you what it is, because you may not know. Then there's the S pillar. S stands for social objectives, like employment equality, gender diversity, product safety, employee health and safety, training and development, animal testing, and so on and so forth. These are objectives. And they are in the S pillar. And then the last pillar is the G pillar for governance, ESG. That's compensation of employees and executives, board and company diversity, tax strategy, bribery, fraud, ethics and values, and so on and so forth. So all these objectives, they've been grouped into these categories, and they have been used at different levels. Regulators, like Solvency II, have taken them and turned into regulation. Asset managers, like BlackRock, have taken them and created products which are aligned with this. In case you have clients who care about this, I have your product. And this is consistent with what we've learned here. We know that in the act of asset management, the management fee is what matters. That means that if someone wants something, you gotta have a way to sell it to them. And it's not that BlackRock agrees or disagrees with this. That's none of their business. Their business is not to agree or disagree. They service their clients. If their clients want something, if they have someone who thinks like Harvard, then they should service them. And they do it with these types of products. So I have a video here, and this I do want you to watch. So maybe what we do now is just about 10. Let me have a 10-minute break. I'll change the audio, and I'll show you this video because I want to show you what Harvard is like today. Remember, Harvard is the one that in 1990 made the decision to divest from tobacco companies. Okay? I want to talk about Harvard today. So 10-minute break. I change the audio, and we come back and I show you. So I'm going to play this video for just a few seconds. I'm not, I like the contrast between Harvard 1990 and what's happening today. And actually, at the end of the day, prove that there's no contrast.
This is democracynow.org, the War and Peace Report. I'm Amy Goodman with Nermeen Sheikh. We turn now to Harvard, where students are continuing to blockade key administration offices while calling on the school to divest from fossil fuels. Harvard has the largest endowment of any university in the world at $36.4 billion. The protest began on Sunday when students began blockading Massachusetts Hall, the school's central administrative building. Several alumni of Harvard have also taken part in the blockade, including Bill McKibben, the founder of the group 350.org, and former Colorado Senator Tim Wirth. The protests are being organized by the group Divest Harvard, which produced this video.
We are Divest Harvard.
We're students, alumni, and members of the community calling on Harvard to divest from fossil fuel companies
In order to stigmatize the fossil fuel industry
and open up space for political action on climate change.
Fossil fuel divestment means taking your money out of investments in fossil fuels and instead putting it into more socially responsible companies.
Our message is simple. If it's wrong to wreck the planet and threaten millions of lives, then it's wrong to profit from that destruction.
Harvard professor.
So I'll leave it there. Okay, that gives you an idea. And there's a number of things that I want to say now. I want to make a connection between this and the GameStop example we discussed the other day. It's the same. is the same. You can agree, you can disagree, but that social trend is there. And this is new. This has never happened before. You can even argue that what happened in 1990 is the same, but it was to investors. Okay, now is... So these things are happening, and I think there's something to that. So let me talk a little bit about climate risk. It's very much in the news these days. I just want you to know some of the facts and the fictions of that. So when it comes to climate change, you may have heard that, I'm assuming you know a little bit of what it is. I don't know how much information you have about this, but the objective is to decrease the CO2 emissions that we produce right now. Okay, so let me tell you about CO2. CO2, first of all, we're very lucky we have CO2 on Earth. If we didn't have CO2, many bad things will happen. First of all, CO2 is the molecule of life. You need CO2. Living creatures produce CO2, they consume CO2. CO2 is the molecule, it's called the molecule of life, so we need a second. It's been very beneficial for us because CO2 has kept the temperature of the Earth at a very comfortable, I think it's, I forget, 18 degrees or something like that. Without it, the average temperature will be at like minus 10 or something, and Canada will be a horrible place to live. Why? Because CO2 has a very interesting physical property. The physical property is it's CO2, it's a molecule of carbon and 2 oxygen molecules, and more or less shaped like that. When certain radiation hits it, it makes it spin. It spins. And you know from thermodynamics that if something spins, that's temperature, it creates heat. So what makes it spin is we get radiation from the sun. The radiation from the sun just ignores that molecule, doesn't. But as it hits the ground and gets reflected back, those reflected radiations makes the molecule spin. It's called the greenhouse effect. I actually think it's the wrong term. It should be the microwave effect. Because everybody has a microwave and not everybody has a greenhouse. So I think it's better understood. What happens when you put food in the microwave and you turn it on? The oven sends some frequencies. They've been calibrated to make water molecules spin. That's why if you put it there, anything with water gets hot. Anything without water does not get hot. So the plate is cold. If it gets hot, it's because the water in the food warms up the plate, but the waves do not make the plate hot. And if you put metal, forget it. It's gonna get warped. It's gonna be a disaster. Don't do it. Okay, don't even run the experiment. So that's how microwaves work. It is exactly the same physics as the microwave. So when you have a lot of CO2, that gets very hot. If you have very little CO2, then the Earth will get very cold. And these are effects which are very minuscule. I mean, the Earth is not going to get at 100 degrees like the microwave when you warm up your food. That will be very, very bad. But it'll get somewhat warm. And if the Earth gets somewhat warm, then everything we know will change. We live in a state of equilibrium. Not exactly an eigenvalue, okay? But we live in a state of equilibrium, and we like it. It's great for us. If that gets altered by, say, 3 degrees, it's considered that 3 degrees will be a big enough change that then everything around us will change. They say that the objective of a climate movement is to save the planet. The planet does not give a damn. The planet is going to be fine. It's the humans that are going to suffer. The plants will adapt, animals will adapt. The humans are going to have a very bad time because we love this stable environment in which we've learned to do things. Okay, that's the thing. It's not about the planet, it's about us. Okay, we like to live in the conditions that we have. And if those conditions change, we really don't know what's going to happen. We're not prepared for that. So that's the whole point. CO2 occurs naturally. In fact, it is the molecule of life. It happens when things decompose. A lot of the CO2 comes from the ocean. That's a little bit scary because a lot of the... So it is true that CO2 has been rising. I don't think if I have this here, but the levels of CO2 that we have had for the last hundreds of thousands of years, it's been at a very comfortable constant 200-300 parts per million. The CO2 is, there's so little of it that we need to count it in parts per million. Percentage doesn't work, even per thousand, it's parts per million. And now we're at 400. We are the highest in hundreds of thousands of years. Not ever. There were times, we know, science have told us that there were times when the Earth had, I think, 6,000 parts per million during a lot of volcanic eruptions, and who knows, I mean, there were no humans, by the way, at that time. In fact, there is a conjecture, which is plants developed, photosynthesis developed randomly because of such high levels of CO2. So CO2 has been very good for us, right? But now we've learned to live with certain levels, and the levels go up, then we think that's going to have an impact on the distribution of temperatures, and not just the temperature, whether they say it's a global warming. It's actually much worse than that. If it's all global warming, if it's a parallel shift in temperature, it's bad, and we don't know how we'll adapt to that. But the problem is not just global warming. It's the warming gradient will change too, and this is what creates storms. And a lot of the natural disasters that we observe today may be very well linked to not the increase in temperatures, but the fluctuation in temperatures. Okay, so the things that we don't know, it is a risk factor that we would have preferred not to have to deal with, but now we have to deal with, and we're not really prepared for what that's going to bring to us and what we should do against it. We don't know, so we are very and CO2 is one, but it's not the only one. There are other gases which methane is much worse than CO2, meaning the radiation, the secondary radiation, when it hits the methane molecule, which is a carbon molecule and 4 hydrogen molecules around it, spins much faster. And there is something called the global warming potential. This is the effect that these microwaves will have on that gas to make it more warm. And methane is 80 times worse than CO2. So if you release methane, that's worse than releasing CO2. That's why you may have seen in some plants, especially plants that produce methane, they have big chimneys, and what they typically do with methane is they burn it. You may have seen chimneys with fire coming out of that. That's methane being burnt, because we'd rather have CO2 than methane. The only good thing about methane is that it oxides and becomes CO2 fairly quickly. In about 10 years, a methane molecule will become CO2 by oxidation, and then the warming potential drops back to 1. So, but there's one which is worse by all counts, which is a nitrous oxide, NO2. It's an oxygen atom with 2 nitrogen atoms next to it. And again, the secondary radiation makes it spin a lot faster, 300 times CO2. And it takes 100 years to oxide. Its lifetime is 100 years, so it's very bad. This is the reason why diesel cars were for a while on a course to be phased out. You may have heard that. And then someone discovered there's a molecule you can add to the NO2 so that it doesn't... there's a molecule you can add to the diesel fuel so that it produces a lot less NO2. Sorry, I said it wrong. And if you ever drive a diesel car, you will see that there is a tank for the diesel fuel, And there's a tiny, typically blue tank for a liquid that you have to put every, I don't know how many thousands of kilometers. I don't know if you know that. Yes. One of the brand names of that is AdBlue. I don't know if there's many brands. You may have seen that. So if you ever see that, that's the reason, is to ensure that, because NO2 is very bad and it's produced through diesel combustion of diesel engines, not gasoline. Gasoline doesn't do NO2. It does other things, but not that. So, so you can see these things are happening, and there's advances being. We're advancing. We're getting on top of these things. All these three gases have the characteristic which they arise from natural sources. Nitrous oxide is in the soil. It comes from volcanic eruptions, and you don't need a lot of it for it to be very damaging. It's in the oceans. Methane comes from respiration, and actually methane was one of the early reasons why people were against it in meat, because farming cows is a very big producer of methane. So all of these have natural causes, which is why we have them, and also what's called anthropogenic causes. This is the humans creating them. And nitrous oxide, for example, is in fertilizers, and we need fertilizers for that. So now these are the ones which they're natural, and we need them in certain proportions. We need a little bit of CO2, not too much. Methane, I don't know that it has any particular use to keep the earth warm. Maybe it does. Maybe it's responsible for the fact that the earth has this nice, comfortable temperature. But when we have too much of that, then we'll get hurt. And then there's the three next ones, which are only anthropogenic. They are not created by natural causes. One is the HFCs. And the HFCs, they've been practically eliminated. These are the ones that they were very famous decades ago for something that you may not have been exposed to, and that was another a planetary challenge, and that was the ozone layer. Have you heard of that? The ozone layer? Okay, so the ozone layer is this gas, apart from being a greenhouse or microwave gas, it had another effect, which is that it interacts with ozone and just makes it disappear. And we need the ozone layer for protection from certain types of sun rays. So this has been mostly phased out, and which is the reason why the ozone layer is now coming back, and no one talks about that anymore. So a lot of these things, they have solutions. This is not, we're not going against a problem unless we solve it. And perhaps also to be a little bit positive on this is, when I was growing up, the big risk that was mentioned was not this. We weren't aware of that. The big risk was global food supply. People have done calculations, and they saw that with the existing food supply, we can only sustain, I don't know, 1 billion people, or I forgot what the number was. And the solution to that was very small changes in agriculture. They talk about the Green Revolution and this and that, which created food for everybody. Well, those solutions were very marginal increases. 3% here, 1% there, nothing radical, and that engineering mostly was responsible for that. And now no one talks about food supply. In fact, you have the opposite of people like Elon Musk saying that we're not enough, we need more people. Okay. 50 years ago, 70 years ago, people were saying the exact opposite. So, but that's what happens, you do things and then things change. But the thing is that humans, we like stability. We like stability. We don't like changes. Perfluorocarbons is, for example, produced when you have aluminum production. Look at these numbers. The global warming potential is 25,000 times the one of CO2, and they live for thousands of years. So these things are, once they're there, they're there, right? So this is the reason that's causing a lot of this discussion. So who contributes to greenhouse emissions? So this has been codified. The codification is a bit more granular than what I'm telling you here. There's a scope 1, scope 2, scope 3. So you have, first of all, organizations with emission-generating industrial processes. Chemical companies that produce CO2, so that's scope 1. Then you have environments which consume energy and heat. That's almost everybody. Universities are scope 2. This is called scope 2. Okay? Power producers groups which supply energy. That's scope 2. Food and agriculture industries, which also produce emissions, that's scope 1. Canada is very big on that. I'll talk about Canada in a minute. Okay. And then you have scope 3. Scope 3 is not here, but scope 3 is those entities that, for example, finance those who do something. So if, I guess, strictly speaking, if you pay tuition to go to university, you're in scope 3 because of you pay money to one which is in scope 2. Okay. Not so interesting for us. It's very relevant because a lot of regulation is written in those terms, but not for us. So I want to now talk a little bit about what the industry is saying about that. I start with Mark Carney, happens to be our Prime Minister in Canada now, but he has had 3 very important roles. He's the only living person who's been the bank governor of 2 central banks for 2 different countries, Canada and the UK, Mark Carney. And he was the UN Special Envoy for Climate Action and Finance since 2019. Now he's the Prime Minister of Canada. And well, so he's talking about climate change, which is something which is, you can read it, it's there, okay? Set in train, a vicious cycle in which rising sea levels and more extreme weather are damaging property, forcing migration, impairing assets, and reducing the productivity of work. One of the areas that I'm personally involved in is the damaging property, because that is I'm convinced that's going to change the insurance sector. In fact, I have a group working on some implications of that, which is called parametric insurance, and that group is actually led by someone who took this course last year, who is now doing his master's thesis with me, and that's what we're working on. A type of insurance which is appropriate for this type of casualty insurance. The casualty insurance of the past is not going to work here. It cannot work. Casualty insurance is extremely ineffective on one aspect, which is you insure against damages. If you insure against damages, then by law, someone has to check the damages. If this window breaks, I call the insurance company, they send someone, yes, it's broken, I give you, 500 euros to fix it, and then that's it. You get paid. But if all of this business campus gets hit by something, and then there's thousands of windows broken, the person is going to take a long time to go and assess the damage in every one of those things. But if all of Munich now gets hit with a tremendous storm, and then you have thousands and thousands of homes in different neighborhoods, and people have to go around and making those assessments, that are going to take a long time. And if all of Bavaria is hit by this, which is what we experienced, that it could take months, and you have to be with a broken window. Okay, broken window, you can do something, but imagine broken roof. 2 months in your house with a broken roof. Well, I go to a hotel. Well, no, you can't if you value the belongings you have in your home. Imagine your wall has broken. This happens in Florida, which I'm very active in Florida. In Florida, this happens all the time. The house is partially damaged, and you can't go to a hotel. You have to sleep there, because otherwise people will go in and steal your stuff, right? And if it takes 2 months it's called the adjuster. If it takes 2 months for the adjuster to go to your home and assess the damage, well, then 2 months you cannot touch it, you cannot fix it, because then they won't pay for it. That's how insurance works today. How will insurance work in a few years? I can guarantee you it's going to change. And I hope it's one of you who changes it. And you become that. You lead that business. So these are some of the things that are happening. And that's why I want you to be aware of these things. Don't assume things will continue to be the way they are. No. So what is the financial sector saying? I have 3 quotes. One is a very important person in Canada, Barbara Svan. She happens to be the president of the University Pension Plan of Ontario, so she manages my pension. This is not the reason she's here. She's a good friend, by the way, but she's been very active, very vocal, saying our financial systems can and must play a critical role in financing Canada's transition to a climate resilience net zero future. I'll explain to you what that means. This is Jamie Dimon, CEO of JP Morgan. his sentence is a very banking sentence. It's very important to read that sentence because it says, immediately actionable opportunities might require more financing, not less. What is he saying? Someone needs money, I have money. I'll make my business your business. That's what he's saying. That's what banks do. So if there is fund flows going somewhere, the banks will be there. That's why banks are all over this, because they're there for the ticket. Remember the $9 in our trading example? That's why they're there. And that's what he's saying. Okay? A lot of these act in the interest of their own organization. Some banks have to be there. This is not a matter of fulfilling someone else's social agenda. Banks are not there for that. Banks are not there for that. Banks are there because someone needs money. They're going to go and produce the money and charge you 1%. And this is the CEO of one of the biggest banks in Canada, the Canadian Imperial Bank of Commerce, CIBC, and basically says something similar. The economics of change and sustainability need to work, which they do when they're constructed the right way. I mean, he's speaking to his shareholders clearly, but that's where he will be as a banker. So a lot of what is happening today was conceived a long time ago. And I want to talk about Kyoto 1997, because a lot of these things are now old. 1997, that was a long time ago. And what was discussed in Kyoto in 1997 is still being implemented, but now it's been implemented very fast. People said it in 1987, everybody knew it was correct, everybody knew it was the right thing to do, but the mechanisms were not there to make it happen. And the idea was to create an economic incentive to reduce emissions. So now I'm talking about climate, I'm not talking about water, I'm not talking about anything else, just climate. Emissions in particular. So if you want someone to reduce emissions, you have to figure out a way to pay them to reduce emissions. Otherwise, they will not do it. And years later, 20 years later, roughly, the Paris Agreement happened in 2015. It was ratified by all but 6 countries. Iran, Libya, Yemen were 3, and some others. And now the United States has left the agreement. So there's now 7 countries are not part of that. Okay. And the most interesting part, there's 2 articles that I want to tell you in a little bit of detail because they are going to have a big impact on financial markets. It's Article 2 and Article 6. Article 2 has this Article 2.1c, which says, blah, 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 making finance flows consistent with the pathway towards low greenhouse gas emissions and climate resilient development. What does that mean? What that means is that the reduction of emissions is going to be done through financial means. Money is going to be used to reduce emissions. That's why the banks are there. Who has the money? The banks. Okay? And what is this? This is an announcement that there's going to be a financial sector whose job is to make Article 2.1c. So that means that there's going to be a new business opportunity around Article 2.1c, and that's why I want you to be aware of that. Because that's going to be an opportunity very different from the opportunity that exists for other reasons. And one of the things that it also did is it paved the way for something that is only beginning to happen now. And this is the new capital market. It was conceived in 1997, it was announced in 1997, but only now it's beginning to happen. And that's the creation of emissions exchanges, CO2 exchanges. The way it works is you have 2 types of participants, those who emit and those who capture. So you emit CO2 through industrial production, picture is there. You emit CO2 through agricultural activity. You emit CO2 through mining activity. And then you have those who capture carbon. And I'll explain to you what capture means. The obvious one is I plant a forest, the trees capture carbon, and they grow at a certain rate. But there's other ways in which you can capture. The definition of capture is every activity is given a baseline emission. If you emit less than that, that difference is considered to be capture. An example, there's a company, I forgot where, I think in Ireland. It's a cement company. Cement, concrete, right? Producing cement is a very carbon intensive activity because the way you create cement is you take limestone, you grind it, then you have to heat it to over 1,000 degrees to create concrete. And how do you heat it to over 1,000 degrees? By burning stuff. So this is a company who has figured out a way to do that where the emissions are much less. Okay, you get that credit. A very big market for this, and we're talking about that, you and I, the other day, is airlines. Airlines are emitters of CO2. I don't know if you've ever bought a ticket and neutralized the emissions. Have you ever done that? I do that all the time. Okay? I do it all the time. The university allows me to do it. In fact, the university goes and does it again. So every time I fly, I'm carbon negative. Okay? Just. But airlines typically, they give you the option to do that. You buy your ticket, you pay 100 euros, and then for 1 or 2 euros, you can neutralize your carbon footprint. Some people pay. Yes.
Are you sure it's 1 or 2 euros?
Say that again?
Are you sure it's 1 or 2 euros? Because I'm flying to America in a month, and I also have to neutralize that, and that was 50 euros.
50 euros?
Yeah.
Oh. Where are you going?
New York.
New York, 50, that's New York. New York is, for New York is probably right, yes. So I'll give you, okay, now we're talking about numbers. I love this. Okay, so let's talk about that a little bit. It's coming up later, but I'll discuss it now. If you fly to New York, I would have guessed that you pay $20 or $30. I think 50 euros is a bit too much, but I'll tell you.
With the airline, but via a separate independent site that also
Okay.
considers.
Yes. But that But that independent company was you were sent to that by the airline, right?
No.
Oh, you did it on your own.
I do it on the
Okay. So this is perfect. So let me use. I scrap now my slides and I'll talk about this because this is how this market works. This is very interesting. So there is an exchange. So I have a factory and I have a forest. So let's change that. Instead of the factory, I have a picture of Ole there. Okay, you're flying on your plane like that. Okay, or me flying on my plane like that. Okay, and this is not written. I'm now unscripted. Then you're emitting something. Okay, how much are you emitting when you fly? Well, it's very simple to calculate. Very simple to calculate. Airplanes know exactly how much fuel they use. They know exactly how many passengers are there. There's a very simple adjustment for those in business class and those in economy class. Those in business class consume about 3 times those in economy class. Okay. So as a result of that, it's a very simple arithmetic calculation. You consume, let's say, 1 ton of CO2. Why? Because there's 400 people in the plane and they know it's 400 tons. By the way, why is it 400 tons? Well, the airplane has about 1,000 liters of that, about half of that becomes CO2. All of these things are very well known. Very, very easy accounting to do. That accounting is very easy to do. So we know that you consume 1 ton of CO2 flying to New York. All right, so 1 ton of CO2. Now I need to get someone who says, oh, I will capture a ton of CO2. Let's say it's someone who has a forest, planted a forest, and every tree captures CO2. By the way, this calculation is the master's thesis of Franziska Stickling, who was the film student 2 years ago. This calculation, okay? That's what she did. So what is the capture of a tree? Let's say it's about a kilo per year. It's more than that. But then I work with a very round number, right? So it's a kilo per year. So that means that every year I capture a kilo. So your flight will be neutralized if I have 1,000 trees. These numbers are not working very well, but the final dollar amount will work. That's the advantage of dollars, right? There's only one. So your ton is going to be captured by 1,000 trees in a year, according to this calculation. The number I'm using is wrong. You're going to get the right number in about a minute. I'm improvising. But now everything will be fine if the company that sold you the credits agrees on the price to the company that's doing the capture. They have to negotiate now. How much? So if the tree grower says, oh, you have to pay me 10 times that, then suddenly your neutralization will be very expensive, will be 10 times that. So there's a pricing mechanism just like any other security. You offer and you ask. And when the bid and the ask converge, that's what the price is. Mm-hmm.
So on the project I've been working before, it says there's also the arbitrage opportunity because many of the people, they try to just say that the forest is planted somewhere else, which is much cheaper than in another country.
Right.
They consume CO2, maybe in China.
Yes.
And they say, okay, now
Yes.
we buy this content from
Yes.
Africa, something like that.
Yes, so this is Article 6. So I'm talking about later. So, but now let me talk about everything all together, and then when I go to there, and then it'll be a review. Now we're going to do a little learning here, right? So, where is that forest? Let me now adopt where is that forest? That forest has to be, you're going from, let's say, Munich to New York, let's say, all right? Does that forest has to be in New York, in Munich, or in Zimbabwe? It doesn't matter. It doesn't matter. If you capture CO2 is everywhere. You can't say, no, this is the German CO2, and there's the Luxembourg CO2, and there's the Poland CO2. You can't do that. CO2 is everywhere. And the way these markets are done, and I'll explain to you how this is done, is if CO2 is captured somewhere, it counts. Of course, to plant a forest in the middle of Munich would be very expensive. So no one would plant a forest in the middle of Munich because it's just not economically viable. But if you plant a forest in the middle of Canada, I'll talk about Canada in a minute, then that's very easy because you have lots of land. Oh, forest, be my guest, plant your forest, right? And then you get paid for that. So there's a pricing mechanism between those who buy credits, in this case it's you, through that company, and those who sell credits, the ones who capture. But you have to agree on the price. In principle, that if there's only one supplier of trees, they can charge whatever they want. You have no option. You have to pay 10 times, 1,000 times the price because the supply demand is in balance. But if a lot of people are offering capture opportunities, then you have choices. And of course, you're going to go with the cheapest. And that's a very interesting market. A very interesting market that's happening. Just to give you an idea of the size of that market, China, who is probably the most advanced country in these things, is going to create, just for airlines, a market of $1 trillion in the next 5 years. Trillion with a T. Which means airlines will be buying $1 trillion worth of credits, and some will be producing $1 trillion worth of credits at a price of about 10 euros per ton, which is about the right price in China right now. That means you're going to have 100 billion tons of CO2 that needs to be captured. How are you going to do that? That's a massive project. But China is doing that. They are going, but the thing is that China doesn't have to do that themselves, or the Chinese airline doesn't have to do that themselves. In the case your company doesn't have to do that themselves. What they can do, sorry, new paragraph, new paragraph. Now you can do this trading in two different ways. You can, there's two markets. One is the voluntary market, that's your market, voluntary. If you don't do it, nothing happens. They still fly you to New York, right? And they give you your meal on board and your luggage gets delivered. It's all the same. That's a voluntary market. You buy it because you want to. So let's say that you decided to do that. I did it too. I decided to do that. And I didn't have a reason to do that. But we're very small buyers. Shell, the Shell Corporation, has announced that they're going to buy over $1 billion of voluntary carbon credits. They're not forced to do that. They just say, I'm going to do it. So why do they do that? Why do I do that? Why do you do that? Now we get into the cost. Why are we doing that? It's a voluntary market. No one is forcing us to do it. Well, we do it. Some companies do it because they want to look good, right? My favorite example is Apple. Apple has invested so much on their image that for them to look carbon neutral is good, it's important, has value to their business. So of course they will spend whatever it takes. It's a very image conscious company, right? I do it, maybe because of my conscience, maybe because I have the money, whatever the reason is, everybody, but it's a voluntary market. Then you have the regulated market, because countries, I went quickly through that, but it's coming up later, then I'll just jump up. Countries have committed they're going to meet certain targets. The European Union has committed they're going to meet certain targets. China has committed they're going to meet certain targets. How can you these are the countries. The countries don't do any emissions, right? The emissions are done by the companies or the activity inside the country. How do they do that? What they do is they've gone to the company and say, well, your budget to emit is this. You emit anything above that, I'm going to charge you for that. And that is not the voluntary market, that is the regulated market. It's called cap and trade. I give you a cap and then you trade everything above it. And governments are managing that. That's not your case, that's something different. So it goes to your question now, okay? Because if you have, say, let's pick a country, United Arab Emirates, for example. They have a target and they're going to meet it. How can they meet that target? They plant trees in the desert? Can't do it. What are they going to do? What they can do, and this is negotiated, it's called Article 6 of the Paris Accord. What they can do is they can go to country, they go to Zimbabwe, said, oh, you're doing a lot of capture. Can I buy some of your capture? Say, sure. This much, I accept. And then what they pay goes against their targets for the country. And this is allowed, and it's the only way that some countries can do that. So that creates a huge, huge international market. And this Article 6, which was created in the Paris Accord in 2015, was activated at the last conference of the United Nations called COP, Congress of the Parties, COP, in Baku just over a year ago. So now countries are beginning to implement their Article 6 strategies. These are markets which have not happened yet. Despite the fact that you can buy that, the big markets have not happened yet, and that is countries trading with other countries. That's why I want you to know this. That's why I'm teaching about these things, and that's why this is coming later, because this is going to be huge, huge capital markets at many different levels. At the retail level, like you and me, at the institutional level, like a company with its government, and then at the national level, country with country. And these things some of them have not begun yet. Like Article 6 has not begun yet. It was activated a year ago, and countries are beginning to figure out what their strategy is going to be. And this is where the big numbers are going to be. Now, let me go back to the price that you mentioned earlier. What's the price of capturing? Well, it depends. It's a supply, demand mechanism. On the voluntary market, on the regulated market, the government sets the price. So right now, the government, the most expensive carbon trade that exists is the regulated one in Europe, which is about 100 euros per ton. So that seems to be consistent with what you're telling me. You're flying to New York, that means that you consume half a ton. Sounds right. But actually, no, that's not true. Those companies, they typically overcharge you as much as like 10 times. Once I did the calculation, right? I said, because I did a calculation, how much do I consume? I forgot. We can actually do that, you know. For the chapter for today, please do that calculation. You can do it. All these numbers are there. What is the consumption of an airplane going from Munich to New York? This much. How many people on the plane? Divide. You can even ignore the business class adjustment, just everybody's flying economy. And then you get a number. And then you compare it with how much you pay. You probably paid, once I did the calculation and I paid 10 times market price. I still paid, I didn't think I paid 50 euros. It was much less. But then again, maybe I got a cheaper provider than you got. Maybe, and if you bought it on your own, maybe not with the airline, I don't know. But that market is there. And the thing is, the assumption is that at the retail level, I'm not going to shop around. $10, $15. I know sometimes I pay $2. For short trips, I pay $2. But I also know that some countries are more expensive than others. When I fly Lufthansa, it's more expensive. In fact, Lufthansa give me another option that I haven't seen any other airline give me, which is not only I can neutralize the CO2, I can pay a low carbon liquid fuel surcharge, which I imagine, I know a little bit about low carbon liquid fuels. I imagine what that means is they have a program in place where they are either already buying or planning to buy fuels, alternative fuels, which have less carbon footprint. For example, there's a mix of kerosene with ethanol and this and that, and it flies but that's more expensive. And there are companies that are beginning to do that. The energy sector is going through a fantastic transformation, coming up with new sources of energy, new fuels. I didn't talk about that. It's not photovoltaic, it's not oil. There's, for example, a company in Norway, you can check them out and you can actually write a chapter about them on today's chapter. It's called Nordic Electrofuels. They're going to do an IPO soon, I think, and what they do is they do some sort of fuels which are based on electricity. I don't know the chemistry of that, but there is a lot of progress in coming up with alternative sources of fuel which have smaller carbon footprint. And the ultimate is hydrogen, and it's not mentioned here in my talk, but I'll tell you about that, because hydrogen is very likely where all of this will end. Hydrogen is a source of energy. It can be stored, it can be transported, and then it can produce energy which is 100% clean once you have it. The problem with hydrogen it has two problems, maybe three. One problem is that it's very expensive to produce. You need a lot of energy to produce hydrogen. The hydrolysis process, which is how you produce hydrogen, is very expensive. So what they do is they produce it in places where there's a lot of very cheap photovoltaic energy. You use that to produce hydrogen. It's very expensive, but since that energy is practically free, then you use that for the production. So countries which are very active on that is, for example, Spain in Europe. And I'm told, I saw a plan that actually has a hydro line, so a pipeline for hydrogen that starts in southern Spain, then does some twists and turns, goes under the Mediterranean, and eventually comes to Germany. So Germany can get hydrogen from Spain. We can ship it. The problem with hydrogen is a very tiny molecule So it goes through most metal. You need to have a very special pipeline, so hydrogen does not just leave. Okay, you cannot enclose it easily on a. But these are engineering challenges. You need new materials, and there's a lot of research going on to produce these materials. And guess what? With AI now, a lot of these things, you can do computer simulations. The computers will come up with the right material that you need to fix it. So that's one. And the other is, if you want, for example, a hydrogen car, the problem that you have is imagine the hydrogen has been produced and you have it. Now it occupies a lot of space. If you're going to have a car that runs on hydrogen, which would be ideal, by the way, then you need to take all that hydrogen and you need to compress it so you can actually use it and it goes with you in your car. Well, hydrogen is very unstable. And at that level of compression, which is like 400 atmospheres or something, it's a bomb. So for a big ship, you can do the engineering to contain it. And for a truck, I heard that it's now doable, but for a car, it's too expensive. But as usual, someone, maybe some LLM, someone will find the molecule that you put it into hydrogen and it's safe. And these are the things which are about to happen. And when these things happen, no one will use oil. Very expensive. And it's not about emissions, it's just expensive and uncomfortable. And you have to drill into the ground to get it when hydrogen is everywhere, for example, right? And I suspect that is one of the reasons why I don't know this, okay, but again, part of my lecture today is to give you my suspicions, so maybe correct. I think that's one of my suspicions, is that that's one of the reasons why the German auto industry has not invested in electric vehicles, because electric vehicles will cease to exist very quickly, replaced by hydrogen vehicles. China didn't have the patience. In fact, what happened in China is very interesting. China ran an experiment that was very good. They ran an experiment to see if they could. China had a big problem because they went from 10 million bicycles to 10 million cars in a year. And the cities were not ready for that. So driving in Beijing was horrible years ago. Now it's very good, but it's still horrible. So what they did is, what China did is they did an experiment. Engineers as they are, they say, well, what about if we create electric motorcycles? They have less impact in the city. So that was an experiment that if it doesn't work, it doesn't work. Big deal. You don't risk anything. But it worked. It worked. They managed to deal with the production of the vehicle, the distribution channels for the charging stations and everything. It worked. So because that succeeded, so well, then let's do the cars. And they did the cars. But they already knew it was going to work because they succeeded with the motorcycles where they did not know it was going to work. And that's why China has the big electric vehicle dominance, because they were somehow forced into doing that. But the German or the US or the Japanese didn't have the need. They knew that electric vehicles will cease to exist very quickly as soon as the hydrogen works. So why would they do the big investment for that? So, and that's what's going on. And I don't know if you're going to be involved in those industries, but again, there you have new industries which are being created every day. Once you can get hydrolysis to work, the storage to work, and these things to work, then everything will change very, very quickly. So anyway, so these are the markets who are being created. These are the carbon markets and everything else that goes around that. This is a very big financial sector which is developing. Again, the reason I'm talking about this today, so you're aware of this, because that's where the money is going. have another example here. Yes.
I would like to discuss with you the hydrogen topic.
Yes.
I've invested in this market already. I made a lot of money in the hydrogen market already, hydrogen stocks. might have also divested in just the right time, and the market's crumbling right now.
Okay.
And I feel like from an investor standpoint, I also very much believe the same success story you just pitched us. But I've felt over the years that somehow industry or the general public sentiment and technology has not moved in the direction where many investors' visions were. And at the same time, we've also seen like battery technology evolve a lot, also evolve away from like rare earths that were like hindering this development. And so I see like the shipping industry and the like trucking and this kind of, or also for like aviation, right? This is where I still see it from a technology standpoint.
Yeah.
But for like even for like transportation, for like trucks and stuff like this, and also personal vehicles, my personal opinion, right?
Yes. No, this is so wonderful. Thank you for saying that. By the way, congratulations on making the money. I'm happy for you. But this is very important because, again, this is really science fiction. I really don't know where we're going to go. But let me tell you my educated guess, okay, as to where we're going. I see the advances which hydrolysis is making. So if I look into the future, I said, damn, this is coming. This is coming. So green hydrogen will become a reality very soon. This is hydrogen produced with the sun. Get the sun to, sun, give me hydrogen. Sure, I'll give you hydrogen, right? That, I think, is perhaps the easiest thing we're going to find. And again, because I see how much brain power is being put into that. I know a lot of companies that they have entire divisions going after that. Why? Very simple. If you are the person who can capture 0.001% of the 400 trillion per day that the Earth gets, forget it. You're the winner, right? And that's where the race is there. And now that I see how industrial innovation happens, which it happens inside a computer, and with AI can do, and what it's doing in health, in other areas, for me, I said, this has to happen, and I think it's going to happen very quickly. So that's one thing I wanted to say. Let me make sure that I tell you about batteries at the end, okay? At the end, I'll tell you what's happening with batteries, which is amazing. So that's on hydrogen. Then, of course, you need the other things, which are important challenges. Transportation of hydrogen, stability of hydrogen, to put it there. But let me change topics to come back. What is very likely to occur in the case of automobiles is this notion that you own your car. That's very likely going to disappear. The reason is autonomous vehicles, self-driving vehicles are already happening. They're already here. If they're not everywhere, it's because of regulatory constraints, but they're already here. So imagine, actually the city of Toronto is taking this into account because they have to make plans for how much parking spaces for the next 25 years. So the city of Toronto is saying, I don't think we need parking spaces in the next 25 years because no one is going to park their car. In fact, no one is going to have a car. What do you have? You have an app. The car comes and picks you up and takes you somewhere. So you don't need to park the car. It's not your car, and you don't need to. So if that's the case, then cars will not belong to people, will belong to big companies. Which, by the way, is getting the insurance companies very scared because 25% of the revenue of insurance companies is car insurance, which is a fantastic insurance, very profitable, very predictable, wonderful. They're going to lose it. If people don't have cars, then they don't have car insurance. 25% of the world insurance premia are from car insurance, right? But that's a different topic. Let's go back to energy. So perhaps electricity continues to be comfortable, and then you don't need to make the change. But if you make the right advances in hydrogen development And cars are now owned by big corporations that can make the investment for a zero cost fuel system, then it becomes an investment decision. And they may do it if it's cheap enough. I don't know what's going to happen, but there's 20% chance that it's going to happen. And then at that point, the hydrogen industry is going to become a big deal. But are cars really the big consumer of energy? I don't know. Going forward, I think the data centers are going to consume much more energy than the cars, right? And they will be, I think, from a hydrogen energy perspective, I think data centers are going to be the ones that will be the consumers of hydrogen. And what that will make to world hydrogen markets, I don't know. Because hydrogen is essentially free to produce, essentially free to distribute. The infrastructure investment is big. Who's going to make the big infrastructure investments on that?
That's what the whole market has been.
Exactly. Yes.
30 years, so.
Exactly. So looking at the countries that I go to, I would say for me it's very clear. I know one country that will make the investment in that infrastructure because that's what they do, and that's China. Right? They don't have elections in 4 years. These are like 25-year investment plans. They don't need to convince anybody, convince the boy, no, this is really good, trust me, this is, right? And then the opposition party will say, what, you invested $1 trillion that we don't have on infrastructure? I say, well, but it's really good for us, and in 25 years, then you lose the elections. Who's going to do it? I think in China, they don't act like that, right? In Vietnam, they don't act like that. So these are countries that will say, well, you know what, I'll do it, because that's how they do things, right? And when it comes to people's sentiment, I see a big difference when I go to, for example, China. Big difference. Emirates, of course, the Emirates is what, 1 million population? No, but that's how they, so we're probably going to see, this is probably going to affect the way governments work. And that part, I don't know. Our expert on that is Jan. He's sick today. I wish he could tell us what that is. But and this could be a tremendously disruptive move. And China is what, 25% of the world population? Germany is 1%. Europe is 10%. No, not even. No? So I don't know.
So if you were teaching a class in China and you were asking the students, like, what is your opinion on like the hydrogen market, how hydrogen technology will like shape society in the next 10 years, what would they answer? I
don't know. That's a good question. I don't know. I've never taught this class in China, by the way. So I teach this class in Toronto and here only. And I can tell you, this class is very hard to teach in Toronto because we have a very mature financial sector and talking about, even new technologies and this and that is something which is not, students are not tuned to that frequency. I'm working with some of them. I mean, I have students who are working with me on this, but Canada is very traditional when it comes to finance. But you talk to engineers and they think differently. I talk to engineers in Canada, not about finance, but about engineering. And Canada has a very long tradition in engineering. I don't teach engineering students, not a lot of them, okay? So I'm sure they think differently, so I don't know. But engineering professors to whom I talk a lot, they do think like this. They do think like this. They are no longer concerned with new ways of extracting gold from the many, many Canadian gold mines. They are thinking, how can you produce energy which is free? But this is perhaps an area where I cannot be very useful. I spend my time on academic circles and financial circles. And both of those are areas where this is not discussed. Academic circles are very traditional, sadly. and financial circles are very traditional. The only collective where I see this type of thinking is when I go to China. But in China, it's at the industrial level. Oh, let me end with a story. This is a fantastic story. I was shocked. So I'll tell you what I remember, okay? This could be, what I'm telling you is 50% correct. I don't remember all the details, and as you can see, I'm improvising now. I was there just over a year ago, and I was talking to a professor who was working on one of the most wonderful research projects I have seen. He is trying to make cathodes for batteries from scrap plastic. You can use scrap plastic to create cathodes for high-performance batteries, okay? Car batteries, for example. So this, and told me the efficiency and the numbers, the electrovolts, it was fantastic. And then I said, wow, so you're going to be very rich. And then he says, oh, is 8 of us working on similar problems, competing with each other. One of the 8 would be very rich. And all 8 were Chinese, right? So, but then I find, look, I talked to a lot of people, I talked to a lot of entrepreneurs, a lot of innovators, and I was in Spain, and there's this company that produces batteries, rechargeable batteries, which are like a cubic millimeter or smaller. You can have 1 million batteries in a little bag. Because for a lot of the IoT devices, that's what they need. That's good enough. They accumulate, they're outdoors, they accumulate energy during the day. They store it in this tiny battery. They use it at night. Next day they recharge. So for some of these devices, a battery which is a cubic millimeter is good enough, right? And that's what they do. They do the smallest batteries on Earth. Right? Very soon you're going to do batteries which are like even less than that. 1 cubic micron. I have no idea. I know nothing about that. Nothing. But I know people who know, and what's happening is just fantastic. It's absolutely fantastic. So I know there's going to be a big change, and that's going to change the financial sector because it's going to change the centers of productivity, not production, productivity. Like who's making the money? These guys are making the money, right? That's going to change. Is it going to be hydrogen? I don't know, but something will. And it's going to change the insurance sector. It's going to. I wish I knew. But you clearly have some very good views about this, and I should learn from you. Maybe you should go for lunch and tell me. But what you said is great, because this is what I wanted everybody to see today. That wherever I spend this week talking about, the principles will be good and will be there for a long time, because I did focus on the ideas and the math. But going forward, the applicability, the area of applicability could be something completely different. And this is not going to happen, when you retire. No, this is going to happen in the next 5 years at most. So, okay, I'll continue. I have another example here. This is a very good example, and I did it also as a way to see if we can. This is a project that was done in Kenya by a company, a Dutch company, Vestergaard. And what they did is this. They produced 880,000 water filters that they shipped to Kenya for 4.5 million people. Okay? What happens? What happens is this. In Kenya, the way they make drinking water is like that. And after these filters, the way they made water is like that. So you hire a consulting company, hire your KPMG, they do an analysis, and they see that this has saved 2.7 million tons of CO2 per year. How much money is this?
More than 100 million.
Sorry?
More than 100 million.
It depends on the price, right? So, and at the Chinese price, which is the cheapest, that will be 27 million. At the European price, the most expensive, will be over 200 million. So, what's the income or the revenue per filter? It's about $10. Order of magnitude, right? So that gives this company an increased revenue of $10 per filter. How much is this filter worth? I have no idea, but probably a little bit more than that. That's a substantial revenue, right? And this is part of the carbon market, which was created as a consequence of the Kyoto Agreement. Another example of new money being created, new capital markets. So I have here a schematic, and it's very old data. I couldn't get the most recent one, but so I want to focus not on the price per se, but on the different types of carbon credits that you can get, because there's no unique. So one ton of CO2 is worth differently whether it's done, whether the carbon is emitted through aviation, whether it's emitted through agriculture, or things like that. They have different, so there's different currencies, different carbon currencies. Okay, and I have them, four of them here. Corsia, for example, is the Platts CEC, and these are numbers from S&P. S&P is the one that uses this terminology. Carbon markets. So, and these were the emission targets of the countries. Well, this is not interesting. We are way past that. But this is the type of reduction that the countries have. This is of interest to me because I have worked on this, and I want to share with you something I did. I mean, it's 11:20. I'm reaching the end of. So I'm going to see. I had more material, but I want to address one question here, which is a question. It's close to my heart. This is how I got started in carbon. I'm going to tell you the first thing I did in carbon many years ago, hoping that if it worked for me, maybe it works for you. What can I do? So in the Paris Agreement, the countries met and they argued with each other and they fought with each other, and in the end, I guess, they did what the United States wanted them to do, I guess. I don't know. So the United States, their objective was to reduce emissions from the 2005 levels in 2025 by 26%. So in 20 years, you reduce your emissions by 25%. It's 25 now, but they left, so they said, they do whatever they want. The European Union wanted to reduce emissions 40% below 1990 levels by the year 2030. Very aggressive. Very aggressive. Okay? Highly criticized, by the way. Highly criticized because I don't know if the criticism is right or wrong. I don't know enough. The criticism is, where do you get this number from? It looks great, but can you do it? That's the criticism. And I haven't heard any policymaker in Europe say, yes, we can make it. And these are the reasons. What I have heard is a lot of bravado. Oh, we will make it. Oh, yeah. Right? China, they want to peak their CO2 emissions by the year 2030. That means that they will never emit more than they will emit in the year 2030. And reduce the CO2 intensity from 2005 levels by 60%. That's 3 times the United States. And as you're about to see, the United States emits twice the emissions of China. So that's a very intense objective, very intense. India and Canada. I have Canada because I'm there. Okay. So now I want to ask a different question to us, which is, where are these numbers coming from? Are they based on science? Are they based on math? Are they based on?
Why it's always 2005?
I don't know. And you see, it's different from different countries, right? Because China is, Europe, they took 1990, right, as the baseline. This is called the baseline. So for this is my baseline, I'm from here, I'm going to reduce or something, right? That's called the baseline. I don't know. Simple enough question. We can ask ChatGPT maybe, but I don't know. But what I want to address is, where are these numbers coming from? And what I will end with today, and now I may have to take a shortcut, because where I wanted to end is with another question, which is, it is accepted that to be there, you have to become poor. You have to stop industrial activity and this and that. And I said, why? Let me ask, and that's the last question I will answer. I was planning to answer in my course today, which is, can I go there and still increase my GDP? That's the question. I will answer that question today. Actually, when I give you the answer, I'll tell you exactly how, something that we have done. Was done actually by some other student in this class of a few years ago. Luis Gansloser, I don't know if you know him. So he did that. Okay, so for me, these are the problems that are worth thinking about, and that's what I do. So where are these numbers coming from? Well, let me. So another thing. Every time you see something new, you see financial innovation. It's always been like that. I don't think I had a chance to tell you, I think I mentioned it, the derivatives market was created. Why? Because of the US-Iran war. The US-Iran war was horrible. It was not a war with bombs. It was a war of an oil embargo that made oil a precious commodity. In the United States, people have to line up for hours at a gas station to fill the tank in their car. Price was very expensive. Industrial production was in great stress. That created tremendous stress to the financial sector. 6 banks defaults per year. I don't know if I told you. I forgot if I told you these numbers. So that uncertainty in interest rates and inflation and this created the insurance against uncertainty, and this was the derivatives market. So the derivatives market was created because of tension. Financial innovation is always there for a reason, and this cannot be an exception. There is going to be financial innovation here. It's already happening, and more is going to happen. That's why you need to know about this. I cannot tell you what type of financial innovation will happen. I really do not know. Even carbon markets, which are beginning, I don't know how big they will be, or whether there will be carbon derivatives, or what's going to happen with that. But I want you to be aware that this is happening. Because when you get confronted with an opportunity, I will not be there. Okay? So, and on top of that, I mentioned Article 6. So I'll just go quickly for this because I already told you. There's Article 6, which contains 3 main sub-articles. Article 6.2, 6.4, and 6.8, sorry. Okay? And basically what that points to is a parallel carbon market, which is between countries. So you can imagine how big this is going to be. And I have some comments about the size of these markets. It is $1 trillion in ESG labeled bonds and $30 trillion. And this data is from 2024 in ESG funds. So this is bigger than the US economy. We're dealing with very big markets, which are much, much bigger than anything we know. And they're happening now. So I cannot end my course without making you aware of these things, because that's where a lot of the money is going. And this is the Securities and Exchange Commission declaring that carbon trading is a security. This is equivalent to what they did in 1980 when they declared swaps to be a security. So get ready. Once something is declared a security, people can buy and sell with the confidence that the regulators will protect those transactions. No, let's take a break now, okay? I don't know what I will do with the lunchtime. We'll take a break. Yes, 10 minutes. Then let me address the topic. This is the first problem that interested me in this area. We have seen these national targets of the countries, and my question is why? That's my first question. My second question is, can you achieve those targets and still be richer? Because that's going to be a much easier way to sell this to the public, and it actually should be the right strategy. So I'll tell you how we are approaching that. I start with this table. I think it's a well-known table. It's quoted very often. I don't know when it was done. It's 2016. It's old. I mean, so the numbers have changed. I'm not interested in the changed numbers. I'm interested in this one. For now, it doesn't matter. And what this says what everybody says. China is the very big emitter. Okay, they emit a lot of 10 gigatons. And then second is the United States. They emit half. And the way people look at this table is by looking at the numbers, but not understanding the numbers. And here I like to quote Paul Erdos, the Hungarian mathematician, who says that a mathematician is not someone who knows how to add, but it's someone who knows when to add. And here these numbers are not significant, amongst other reasons why. Because imagine I do this. I look at the emissions on a per capita basis. I divide by the population. Clearly, China has a huge population, has a population which is almost 10 times the population of the United States, but they only emit about twice. So clearly, if you do the emissions per capita, then you can see that, of course, China disappears from the equation. The United States is not dropped. It was in place, second place to place 15 or so. But then what happens is that the small countries show up, because obviously they have a small population, so you divide by a small number. Interestingly enough, Canada is number 7 in absolute terms and is number 7 in relative terms. And the reason is that Canada is a very large country with very few people, with a lot of agricultural activity, which produces a lot of CO2. So what are you going to do? If you want Canada to be more efficient, should Canada just eliminate the agriculture? That would certainly help, but that's not the intent. So the problem I wanted to tackle here, I'm a mathematician, so I wanted to understand where these numbers come from. That's the first question you should answer if you want to decide what to do. Where are these numbers coming from? They're clearly not coming from population only. Canada is a very good example. The emissions in Canada do not come from the population. If you want, again, Canada will have to have maybe two options. One option is to just stop all the agriculture. And the other is to give 2 our promises to the United States. Alberta, which now there's a lot of talk about that, and Winnipeg. We gave those 2, or even Saskatchewan maybe. We give those to the United States and our emissions will drop, right? But that's not the intent. So if you want to know what to do, you should understand these things differently. So what I did is, with some of my students, we did we try to understand emissions from a socio-economic perspective. We did that with math. The emissions under the United Nations Focus Group on Climate Change, the UNFCCC, Focus something. They have a way to allocate emissions based on your economic activity, and they've written papers about that. They said, that's great, but we're going to do something different. I'm just going to look at the numbers. So what we did is we use a method that you may be familiar with. It's called support vector regression. You may have seen, or you may know that in AI, one difficult problem, if you want to take, if you want to have a classifier that tells you the picture of a dog from a picture of a cat, classifier, then there is one method that is very efficient, and it's the support vector regression. I'll summarize with one statement in case you don't know it. You know what regression is, right? You give me your sample, we have seen it here, and then I draw the line, and that's my regression line. So regression lines take into account all of the information given to you. and they work very well. That does not work in nonlinear worlds, like, for example, cats and dogs. It doesn't work. What happens to work, and no one knows why, what happens to work is a different type of regression, where most of the samples don't matter. You just focus on the samples which are tricky, some sort of outliers. You focus on this and then it suddenly works. In other words, you train your system on those pictures where you cannot tell if what you have is a cat or a dog. Then you label them and you use them on a regression basis. Only those, forget about the rest, and then it works. So it so happens that if we use the same, by the way, this is a mathematical model where you optimize a certain convex function, blah, blah, blah. We do that, and then it turns out that we can explain from a factor perspective what are emissions made of. And what we found is that your emissions are a function of your electricity production, which is surprising. The more electricity you produce, the more emissions you have. But this may not be causality. I'll talk about causality in a little while, okay? It may be just what's called association logic. It just so happens that if you consume a lot of electricity, you will consume lots of other types of power, which is fossil fuels. So it could be association logic. Urban population, that's clearly causality. People in cities consume more than people in rural areas. We know that. So yes, that's exactly what we expected. Population was a big factor, not as important as electricity production. And GDP was actually not a very big factor. It was there, but not a very big factor. And then we had fossil fuel consumption per capita. This is interesting because fossil fuel consumption seems to have a smaller impact than electricity production. And then surface area. I thought surface area was going to be a big deal, but it ended up not being a big deal. But it's still there. So these are the 6 factors that seems to explain. The advantage of this is, and again, I'm not saying that this helps me in any way to reduce emissions. It only helps me understand emissions. And a consequence of this could be that now I can create targets for countries. Give me a year, tell me the parameters of your country, and I'll create your emission targets. In fact, you give me a new country that didn't exist, and I'll create target emissions for them too. You understand what I'm saying? Okay, so this is what we did, and this could be interesting. We created what I call emission chromodynamics. So I will create for each country their emissions baseline. Not going to 2005, not going to 1990. No. Give me your data, and I'll give you your emissions baseline based on your data. Tell me how many people live there. Tell me how much, what's your GDP, right? By the way, linear regression does not work. But support vector regression works. I don't know why. It works. So give me your data, and then I will introduce that system to explain these values. And then this is what I'm going to do. I'm going to paint countries with a color. If you're a country that emits less than your calculated baseline, I say you're green. And if you're a country that emits more than your calculated baseline, I would say that you're brown, with all the colors in the middle, between green and brown, all right? Okay, so this is what we got. This is 16 countries on which we did this. And I don't want to mention names because I'm a little bit aware that if I publish this, then some countries might be offended. And the fact of the matter is that this is just a model, right? And if someone doesn't like it, my answer is, well, do your model, show it to me, and then we'll create a better one, right? So don't shoot me down because of this, okay? So there's some countries, like for example, that one is becoming more and more brown. And there's other country like that one that's becoming more and more green. And I'm doing this entirely from a data science perspective. That's all I'm doing. Okay? Is there a country you're curious about? Tell me. Maybe it's here. Sorry, which one? US? Let me see if I can see this. US. Okay, so by the way, so I'll use so if this is 0, 0, so this is Russia. Okay? In fact, let me see if I can read. Canada is this one here. That's Canada. Okay. US. China is the second one. This one. That's China. Okay. US is the third. That's the US. That's the US.
What about Indonesia?
I don't know. I don't think I have Indonesia. I don't think we had the data for Indonesia. Oh no, yes, it's here. That's Indonesia. Very green, becoming greener and greener and greener very fast. They are on a mission, these guys.
Yeah, I mean they are building a second capital, right?
What?
A second capital city.
Oh, okay. So you seem to know a lot about Indonesia. I would like to know more. You have to tell me what you know.
Not anymore, actually.
Not anymore. Okay.
Because Jakarta is going or sinking.
It's sinking. Yes.
Therefore they are building
Well, according to this model, okay. Again, I don't think this model is it's just the first model. Okay, there's going to be a second and a third and a fourth, and eventually this way of thinking would be good. I think so. If anybody's interested, let's do more. Okay, but it's the first time so I was very happy when I was able to do that. But then I know that this is not going to really have a big impact because I can only explain numbers, I can make projections, but it's not going to help us. If you want to decrease emissions, this is not going to help. And then something else that will help, and that's what I will tell you. So to go there, what I want to do now is I'm going to make some reflections. You already know this, but this is something that I say oftentimes to people, is I want to explain the difference between the 20th and the 21st century. And by the way, my colleague mathematicians don't like this. I like to say that the 20th century was the century. Perhaps the biggest achievement of the 20th century is sending the man to the moon. And if I were the man, not the woman, it's probably a good reflection of what the 20th century was about, right? Okay. All right. So what was that? We had no data. How did we go to the moon? What data did we have? The distance, gravity, that's it, right? But we have lots of equations. And everything happened in physical space in the 20th century. So the 20th century was the century where that's how you did things. But as you know, this is not your century now. Your century is the 21st century where things are different. We have lots of data, no equations. I like to exaggerate, I would say no equations. That's where my mathematician friends, they don't like what I'm saying. But I don't say it because I like it or not, I just to reflect reality. The fact of the matter is that most of the things that happen, we don't know why they happen. No equations. And everything happens in mental space. So to be consistent with this, I want to attack this challenge. And that's what we did. So the first realization is that data is the new oil. You have to understand data differently. And not only data it's going to consist of numbers, it's going to consist of textual data. We went through that. Reddit, we mentioned that. Sensor data, I don't think we talked about that. Images and videos. And there's actually companies which are very actively working on that. Well, you may know some of these companies. All right, so I want to go a little bit faster now. And this is something that we've already reflected. If I look at quantitative methods in finance over the last 100 years, it all started with value investing and everything that you did with pencil and paper. Then we did quantitative investing, which is where Markowitz happened, and there the computer was key. And then the desktop that everybody had. We went through this yesterday, not in this way, but in a different way. And then everything is different with the arrival of AI, because this is what creates a new data that you consume. And that's the big thing. It's not the methods, it's the data. The data changes everything. And GameStop is part of that. And this is creating what I think is the big deal, that social trends is the new momentum trade. We talked about, in Wednesday, we talked about the different trading styles. Momentum was there. Well, I like to say, I think it's true, that the new momentum trades are now social. It's not like Netflix in 2013. It's like the GSG that we saw earlier, that investors, for good or for bad reasons, they decide to not invest in those companies and invest here. GameStop, where a bunch of teenagers, for right reasons or wrong reasons, decide to invest in this company. Okay, that's what's happening. And if that's happening, then what is the data that helps you understand that? So what I have here is a screenshot of a product done by one of my students in his company. A lot of my students have companies, and this is a very successful company. It's called Sibley. And what this company does is in real time, it can analyze a company, give you consumer sentiment analysis, give you impact analysis, give you whatever you want. It has a corruption indicator over time in real time. Human capital, climate change impact, everything in real time. They do many other things, by the way, but I find this to be not shocking because we know in principle this can be done. What's shocking for me is that someone has actually done it. And someone who was my student, and that makes me very proud, right? You know that, right? So this is the new thing that's happening. So what I want to do now is I want to be equipped with this. I want to go back to the concept of sustainability in general, and I want to develop the concept of risk thinking. So I want to spend a little bit of time on risk thinking. I'm going to go very fast through this. Some of the things you probably already know, I don't know. Then I want to go very quickly to what I call causality, which is what will really help us if we want to optimize systems, be it environmental, be it energy, be it financial, doesn't matter. And I want to start with a question. There's a law in every country, there's a law that you have a storm with lightning, then the airport shuts down. No planes leave. Okay, so I like this example because I think I can get everybody to relate to this. Everybody has been on an airplane once, right? Exactly, all right. So imagine a situation where you are about to board the plane and you're confronted with this. No refund, no cancellation, but also no law. The airplane is gonna attempt to take off. Do you fly or no? You fly. Who would fly? Ole will fly. Who would fly? If you don't fly, you lose your ticket. Okay, you cannot rebook. They say, what? Why is they going to? Weird people. They don't want to fly when there's a storm. Okay, so only Ole will fly.
I'm pretty sure Ludwig will fly as well.
Yes, you will fly too? Okay, right, okay. So the question is, how do you think about this? So let's look at the arguments in favor. Maybe this is what Ole and Ludwig are thinking. So the probability says that you're unlikely to have a problem. So why do you worry? And moreover, physics says that if that lightning hits the plane by Faraday's law, it's going to go around it to the ground, you're safe. So these are arguments, good arguments in favor of fly. I've never been able to convince anybody who wasn't already convinced to actually go and fly. And the reason is that if you're wrong, you die. This is the real reason why many people don't want to take this, right? So let's analyze, let's get into this a little bit. Risk thinking is the art or the science of deciding what to do when you don't know what will happen. And I say it's an art or a science because it's at the borderline. And I want to play a game, which is somehow part of this. And this is a game, I'm sure you've seen this game. I'm sure you played the game. And I'm still going to try to play with you. So I'm going to give you two choices. Even if you've played the game, you already played my previous game, and then I know what you think. So you have a game, and choice A is you have a 100% chance of making $900, and then you go home with your $900. In the other one, you gamble. Okay? And you have a 90% chance of making $1,000 and a 10% chance of making nothing. So let me have a quick show of hands. Who chooses A? And who chooses B? No one chooses B. Okay. Let's go to the game A2, where you with a 100% chance, you lose $900, or you can gamble and maybe go home free. Who would choose A?
It was the first.
Hmm?
Isn't this still exactly a one?
No, you
I-
don't know.
What?
You lose.
You lose the 900 now.
It's mine is not okay. Yeah. Okay. Yeah.
Yeah. Okay. So 100 in choice A, you pay me money, you go home. Choice B, we gamble. Maybe you pay me more money, or maybe you go home free. So who chooses A? Who chooses B? Okay. So it's always like, usually there's 10% of the people who go the wrong way. But I'm surprised that Ole and Ludwig don't gamble, because with the plane, that's what you did. The game that we're playing here is the same game we played with the airplane, isn't it? No? How's it different?
It's so much safer.
Hmm?
The airplane is much safer than this.
It's much
Safer.
safer than this. Okay.
It can happen a lot of things until an airplane crashes.
Yes. So the probabilities are different, right? Yes, but the payout is different too. So there's a balance between. So let's go back to the city of Montreal and the ski resort. Day one. The ski resort had a choice, which is to not gamble, just go with save money, or gamble, which is if there's snow, you pay money. If there's no snow, you don't. And the city could have done also the decision to not gambling, and if you gamble, then you get the opposite payment. So many of the things that we do in life could be put into the context of this game. And then we saw in the case of the city and the city in the case of the ski resort and the city of Montreal, the interesting game was to actually go in there and act as the broker between them. And then we give each what they want. Of course, we prefer that people gamble, because if people gamble, then I have a business and I can give you protection. And that's how financial markets exist. So that's a way to understand why financial markets exist. And in doing this, you need to organize your information into 3 buckets. What you know you don't know, and what you don't know you don't know. And we mentioned that also the other day. This came up in the book by Nassim Taleb, and he used the example of a turkey at Christmas. I don't know if you know the American tradition of eating turkey at Christmas, but in his book he says the known knowns is I have a good life, I have food, I have home, I should be happy, I have nothing to worry about. He doesn't know how long that will last, but he doesn't seem to care too much. But the unknown unknowns is that Thanksgiving is coming, and he does not know what that means for him. Right? So he says that. You can take this to many other contexts. You can take this to the Silicon Valley. I'll just go through this quickly. We've seen this example. In the Snow Fund, we had exactly the same situation, which led to the default that we did not know that IntraWest was the owner of the ski resort. So everything we have done can be put into this. And climate risk is there too. There are things that we know, like CO2 warms up the atmosphere because of the effect of the sun rays, actually the reflected sun rays, methane, NO2. By the way, H2O also, I didn't mention that, but water is a very big, very, very big greenhouse agent. The advantage of water is that when there's too much of it in the atmosphere, it rains. So it goes back to wherever it was. So it's not dangerous. It is not going to capture heat, because if there's too much water, the water will just become liquid, and then it does not contribute to the warming. But then there's known unknowns. We don't know what that's going to do to the temperature. They tell us that this is going to rise the temperature of the Earth. Perhaps yes, perhaps no. We actually don't know that this will raise the temperature. This is something which is often misunderstood. People think there's a direct relationship between the CO2 warming up, which we know is true, and that the atmosphere will get warm. We don't know that's true. There's a 25% chance of that. Now, if there's a 25% chance that your airplane crashes, that you consider to be a very big number. But there's no direct relationship. And this is why a lot of the debate happens, because people are not talking about the same parametric space. The parametric space we have is in which we actually don't know that this could We don't know it could cause volatility, which turns into wind or rainfall. We don't know that it's going to melt the polar caps. We think so. We don't know it's going to change the Gulf Stream that will then flow backwards, and then Germany will be colder than Canada. Canada will be a tropical country. We don't know. There's a chance of that happening, but we don't know. Right? And there's other things that we don't know. We don't even know we don't know them. So when you go to the risk thinking, you need to understand what you're doing. And we always make decisions. We typically make decisions in this way. You can take some action, which is miss your flight and lose your ticket. That's the 100%, that's the safe choice. Or the gamble is, if we are lucky, we save money and nothing happens, so you go home free. And if you're unlucky, you die. So that's why I continue to say that this is the same game as the one we played earlier with you. It's always the same game, or it's a variation of that game. And finance exists because these games are played by people with slightly different numbers. The numbers which are small enough, so that it doesn't change people's attitude, but big enough so that brokers can come in and do deals and make money no matter what. The $9 in our banking example of Wednesday, for example. That's how things happen. And if I look at just the loss aspects of things, there's 3 parameters that matter. One is the mitigation cost, the insurance I pay not to have any problem, which is either the price of the ticket, the option premium, if you think of options, or the mitigation cost if you think of insurance contracts. And then if you gamble, the parameters that matter is the loss probability, the probability, and the loss value, or also called the severity when you do insurance. So these 3 parameters are the ones that really become your decision maker. And the relationship between the 3 of them drives your decisions, but it is not what people think. One might think that the insurance premium is the probability of loss times the loss amount, which is the expected loss. Some people think that. I think you know better. You know this is not the case. Not even insurance companies go with this rule, which are very diversified. And certainly banks do not sell options based on this rule. No way. In reality, if you parameterize this, you have scenarios, probabilities, and losses. And they're all different under different scenarios. And you can model this with a probability space. I'll just go quickly through that. The insurance premium is not equal to the expected loss. It never is. That's a simplified version of reality. Reality is a bit more complicated. Even when risks are diversifiable, then this is not the case. I want to show you an example. Again, very quickly, because I suspect this you already know. So I'm gonna look at auto insurance. Imagine a situation where I have the expected value of an auto policy claim is $1,000. The expected claim is $1,000. The probability of an accident is 10%, and one claim is $10,000. Okay, so that is one claim is going to be 10,000, but you're going to make it with 10% chance only. It's very simple model, discrete, no Gaussian, nothing, just very simple, right? So imagine a situation where an insurance company sells only one policy. Okay? The loss function is a very simple Bernoulli. It has a mean of 1,000, a standard deviation of 300. Can I sell this policy for $1,000? That's the expected value of the claim. If you do that, there's a 10% chance you go out of business. We don't like it. It's a very big probability. Can you charge 10% more for the claim, $1,000 and 100? The probability is practically the same, so you're going to go out of business. Let me now assume that I have good diversification and sell 1 million such policies. The loss I can approximate by Gaussian distribution now. It's a Bernoulli with $1 billion expected loss and 300,000 standard deviation. Can I charge $1,000? No, there's a 50% chance you go out of business. You can never charge the mean. The mean is too expensive. But in this case of highly diversified portfolio, can I charge 1,100? Can I charge 10% more? Yes, you can. The probability you got a business is very, very small. So this is how you calculate insurance premium. Again, you knew that, and probably know much, much more than that. But that is a way how we quantify, how we make decisions under uncertainty, when we don't know what will happen. And this is how price and risk is done. And typically the answer is that the price is the expectation of the losses plus a piece of the standard deviation. And that's how option pricing typically works. Okay, so again, you know that. But this is how markets are created. I'm going to give you now another example of a very famous carbon trade, which is the one that was done in Northeast Australia, in South Kimberley. That is the thing there having the map. And this was a tribe from there who are going to get money. This is on the regulated market, cap and trade, from the Australian government. One of the most advanced governments, by the way, when it comes to climate emissions trading. They essentially get paid to burn the savanna. They have the savanna there, and they get paid to burn the savanna. Very interesting. I want to explain to you how that happens. Very quickly, okay? I'm not going to spend too much time. What they do is this. The savanna has a pattern, which is very well understood. It burns, and it tends to burn during the dry season. It's very hot and dry, and when it burns, it's just a disaster. It burns for days and days and days at scale. It never ends. So what they do is they created a company called the Nyaliga Fire Corporation in 2017, I think. And what this company does is they do controlled burning. They hire some people, they do some analysis, and they burn the savanna preemptively in the wet season. And then they do that. And every year there's an accounting done on the savanna by the local consulting company, the local KPMG. And what they have documented is that the area that burns has dropped by a third. The grass and the wildlife are back. That's great. They don't get paid for that. They get paid by the fact that the CO2 emissions have dropped by 40%. So, back to the example I told you earlier. The reason you get paid is not because you capture carbon. No, they emit carbon. They burn the savanna. But they burn the savanna at a rate which is 40% lower than if they didn't do it. So from a regulated perspective, this is substantial carbon capture, and they get paid for that, and that's how they fund the company. Okay? But now here's the interesting part. That I think the interesting part is, I made a mistake. The interesting part is this. This is just some of the pages in the documentation that is needed to get that money. They need an army of accountants that go around, take measurements, and do very detailed analysis for that. What I want to announce is that there's a new business for accounting firms, which is to do that entirely with AI. I'm going to show you another example in which I am personally involved in, and this is happening. So that's another thing in which these things are going to change the way we do things. Because a large language model with good satellite imagery could actually do this very fast. These trades are very costly. They take a long time. And I think we're going to be in a situation where these things can be done in a matter of minutes with images which are already ready to go, being captured in real time. And that is the new finance. It's very rare I can present to you a case where the new finance is so close to actually happening, and it's right here. You understand what I'm saying? I like to if you're not convinced, I like to remind people how stock used to be bought and sold before the creation of stock exchanges. I think we gave you the example of the Hudson Bay, the Canadian company from 1685. The way companies were bought and sold was like that. And now you have Bloomberg, you can trade a company in no time. And I think that's where these markets are going. And if they're going to be so big, they can only be big if that happens. And who's going to do that? You are going to do that. I cannot imagine people different from you doing this. And that's the new finance. This is the new markets that have been developed. This is something I'm involved in. We are doing something, we work with satellite images to get a calculation of all the parameters that matter when you're doing carbon capture projects on forests. You need to know the dry biomass, above ground, below ground, how much carbon has been captured by the trunk, by the branches, by the leaves. All of this goes into a calculation, and then, boom, you get your money. We're actually doing that. It's one of my companies. But this was based on the master's thesis of Franziska Stigling, a film student from 2 years ago. Okay, that's just for your information. You do the calculation of the CO2, and that is, and you can even calculate the value of projects now with that. You can do what's called a predictive tool. Tell me where you're going to do your forest development. Tell me what trees you're going to have, and I will give you the cash flows. That's the new finance. Okay, so I wanted you to see that. All right, so, and now I want to end with what I think is the most important part, and this is really in its infancy. That's how I spend my time, and which is how you can actually do something with what I'm telling you here. How can we proactively do something? And the problem I would like to solve is how can you decrease emissions and become richer? That's the objective. Nothing of what I have told you so far can get us there. We know how to trade emissions, we know how to do. But for that, I want to tell you what causal AI is. And for that, I have to tell you what causal logic is. And I like to talk about causal logic by quoting this book. It's called Unsettled by Steve Koonin, which I think is a wonderful example of how not to think. And I want to show that to you. And what lies at the bottom of that is the relationship, or sorry, two terms, the term association logic and the term causality logic. So association logic is what happens at the same time as what. And causality is what happens because of what. Example of association is correlations. An example of causality is what I want to show you now. So my favorite example of association logic is if you're sick, very sick, don't go to the hospital because you'll die. People die in the hospital, right? The correlation between going to the hospital and dying is very, very high, right? So association logic will say, don't go to the hospital. Stay at home, you'll be fine. People who stay at home don't die. They die when they go to the hospital. You understand? Of course, you know what's wrong with that. But how can we mathematize that? So before we mathematize that, I'd like to address some of the statements that Steve Koonin is making. He says, high emissions are green. He says, more CO2 in our world will make our world greener, more trees. He's right. He's right. It is true that higher CO2 will enhance plant growth and agricultural productivity. It's true, okay? But if I do the causal graph for that, what I see is that that edge in that graph is true. CO2 leads to plant growth. A little, not much, a little, but it does lead to plant growth. But you have to look at the whole causal graph, not just that, right? And the whole causal graph is that CO2 probably, I mean, we know it makes CO2 warmer, we know that. And methane even more, and N2O even more. But then that is where the problem lies. The problem is not in that edge, it's in the rest of the graph. Because this is what creates storms, floods, increased coastline maybe. This is Donald Trump's favorite consequence of global warming, more coastline. Which actually, you need a very weird geometry so that rising sea levels increases coastline. Normally it decreases coastline. You need a very weird three-dimensional geometry, right? For, I don't know where you have that. Certainly not in California or in New Jersey. Anyway, so, but you can do whichever consequences you want out of that. And then the causal graph is, continuous. This is what is causing the loss of life, the loss of numbers, the loss of dollars, and this and that. So you have to look at the whole causal graph. That's rule number one. So you need a whole causal graph. And these are hard to do. You cannot just focus on an edge. You can see very clearly that Steve Kunin's, in my opinion, mistake, I hate to say people make mistakes. He's actually right in his statement, But the thing is, the whole causal graph gives a completely different picture from what that statement says, right? Now, my favorite is this one. He says, high emissions solves hunger. This is the don't go to the hospital thing. It's exactly the same. Because his logic is this. He says, global food production has significantly increased in the 20th century. Actually, this is what I told you earlier, the Green Revolution, right? It was great. As the world experienced warming. So look, we have more global warming, we have more CO2, and global fruit production went up. You see, that's the don't go to the hospital argument. See that? Okay. Because if I do the causal graph, then what I have is, it is true that CO2 and hunger are positively correlated. It's true. So CO2 and the removal of hunger are positively correlated. We know that. But then do the whole causal graph. Hunger has disappeared because of increased food supply and the increase of global supply chains. Not because CO2 did not impact hunger, right? Other things impacted hunger, namely these two factors. And these two factors were created by other factors. Enhanced engineering, agricultural engineering, agricultural mechanics, all of those things increase food production. They also increased transportation, global food supplies. Engineering did all of that. And by the way, these are the things, transportation and agromechanics, that increased CO2. That's the whole causal graph. And correlation should not be used. Correlation will lead you to the wrong conclusions. So what you want to do now is, if I want to, let's say that you want to decrease CO2 and increase hunger, and decrease hunger, can you do that? Can you break the association relationship they have had for the last 100 years? And where you look is at the graph. The graph will tell you if you can do that. These are the variables which are related to each other, and the graph will tell you if you can do that. So in causal logic, there's some terms that I don't know if you know. These are what's called the confounders. These are the things that imply other things. And in fact, there's a whole vocabulary around that. We also have mediators. Mediators are things that are impacted by other things. We have ancestors, things that imply other things. We have descendants, the things which are implied by this. And then when you have a whole graph, then you basically look at if a node receives arrows, sends arrows, and where they go, and then that gives you the whole. And you need to understand all of that to solve that. So I'm going to finish very, very quickly. I'm going to go quickly towards the end. Then once you have a graph, then you have this thing called the graph weight. What's the weight? The weight is a number that you attach to the arrow that sends one factor to another. So this graph is a directed graph. Okay, we need to know that this implies that, not the other way around. This graph has to be acyclic, no cycles. A cycle will be this implies that with that implies that. I don't want that. Then it's not a logic graph. I want no cycles inside the graph. Okay, you start and you go, and they are called DAGs, D-A-G, directed acyclic graph. And every time you have a directed acyclic graph, what you have is not only the graph weight, but you have the causal graphs. You can do linear regression once you know the implications, not before. And the implications will be measured by the graph betas. And only then you know what causes what. And not only that, you know the impact. Whether you change something here, what will happen over there. So now everything I do these days is with a causal graph. I told you about correlations in this course a lot, and sorry about that. Okay, correlations are not very useful. It's better to do things like that. But maybe next year I can. We're working on how to do portfolio theory with causal graphs. I don't have it yet. Okay, it doesn't exist, but we will do it, and then. So that's the way we want to think, and to do this follows a two-step process. Okay, which is what will enable us to do something. I call this causal sustainability. If we want to have impact, what should you do? And this could affect everything from managing a project, managing a portfolio, or in this case, managing a country. I want to address the concept of managing a country. And so we follow a two-step calibration. I want to show you the causal graph that we have in the end. This is the one that Luis Ganslosa did from FIM. He did it. Actually, we're publishing that now, so it's still work in progress, but it's fantastic. So you need to do a two-step calibration. The first calibration is the difficult one. I need to understand what causes what. Actually, even before that, I need to have what my features are. I need to know what my risk factors are. That's the first thing. But that's typically not difficult. In case you thought, you just throw it there. So we work with graphs that have about 100 risk factors. I know we don't have 1 billion risk factors, okay, but we're 100 is pretty good. 100, not like Steve Koenig who has 2 or 3. 100. And then I need to know what causes what. The full network graph, the full graph. We do that with large language models. We have a prompt engineering process where we basically ask the intelligence of a computer to tell me what causes what. We don't want to innovate there. We just go with whatever status quo is. If you tell me that increased fossil fuels increases emissions, I believe it. If you tell me that increased fossil fuels decreases electricity, I believe it. If you tell me the opposite, I believe it too, because I don't know. So I ask an intelligence, what is the implications? Where's the causal? And we build a causal graph like that. And the causal graph is essentially only zeros and ones. I only say what implies what. I don't get into the actual weight of the graph. I just want the direction. That's the first thing we do. We start there. But once we have that, then is when the fun begins. And this is not so hard. Then this becomes an exercise in big data. Then give me data for all the factors, because now I know what implies what. Then I can get, through statistical inference, I can get the causal betas. So imagine now I have a graph that has all the causal betas in it, and I know what implies what. And then I can set up my optimization problem. I want to minimize this with a constraint that this stays constant, and by the way, this I want to go up. You can do whatever you want. Okay? So it looks like that. This is Luis Ganslosa. There are other people too that participated in that. This is the typical prompt that we use. We explain what we mean by causality, and then with this prompt, we go through all there's a lot of combinations, a lot of factors, right? We go through all of them, all the possible combinations. And the result is that. This is the one for emissions. You can't see anything. It doesn't matter. Okay? The important thing for me to say is here we have the factors and the numbers. It's pretty good. So with that, you can create your optimization problem. We haven't done it yet, okay? But that you can create. That's the ultra easy part. The important thing is to have a graph like this that is reliable, because then you can have your optimization problem, and there you can optimize whatever you want. Decrease emissions, optimize GDP, use less electricity, more electricity, and you're done, okay? I believe this is what the future will look like. I cannot tell you exactly how, but I think it'll be something very much like this. So you ever see that opportunity, you raise your hand, take that job, because you'll be well prepared for that. Okay. Good. Thank you. We're done.